All right, I'll open the meeting. So good morning and welcome to the September 14th Hanford Advisory Board Tank Waste Committee meeting. As most of you know, my name is Lindsay Summers and I'm the DDFO here for the Hanford site. As a reminder, this meeting will be conducted in accordance with the requirements of the Federal Advisory Committee Act. I appreciate your attendance today and I look forward to a robust discussion. We had a lot of great briefings.
Thank you, Lindsay. For meeting logistics, as another reminder, this meeting is being recorded. It'll be posted on the website shortly after the meeting. For those in the room, restrooms are behind us, past the staircase, across the hall. And also, if people could set their phones to silent. As a HAB committee meeting, this does operate under HAB ground rules. If you could please keep any side conversations in the room or online to a minimum. If you do need to take a call or have a conversation, please step outside. We do ask that people listen for understanding and assume good intentions as people are sharing their perspectives. It is going to be a full day with 3 presentations. Rob is going to take us through the agenda review, and it promises to be a great day for content.
Hello, everybody. Welcome to the meeting. I'm the chairman of the Tank Waste Committee, and Rob Parmalee is over here to my right. He is the vice chair. Today's meeting has got a couple really interesting subjects that we're interested in. The first, we're going to talk about the ETF upgrades. Remember Ricky Bang teased us with this a couple episodes ago, a couple meetings ago, and we're really interested in learning about the water burden being coming from the WTP operations and how we're going to handle it. Then we'll have questions and answers and discussion. We'll take a break at 10:15. Then we get to talk about with Becky about interim service barriers, which is real important now, what we're doing, and we've got lots of questions on those. Then we get a commissioning update at 11:30. We can come back and we have lunch at 12:30. And we have an open forum in the afternoon here. And this open forum, I'd like to, I prepared a little presentation that I'd like to have members review all the good quality presentations and information we have in the past that really help for the basis of our understanding of what's going on the tank farms. So with that, let's go ahead, Judy.
Very good.
Thank you.
Does anyone have announcements that come to bear on the Tank Waste Committee or the work of the HAB in general? Chris?
There's a lot of leftover cake from the BCC. I'm still on a sugar high from trying to diminish it last night at home. So please, when there's a break or you're feeling a bit peckish or you need to pick me up, it's behind me.
Thanks, Chris.
What was the cake for? What was it for?
Party, farewell, BCC.
Yeah.
And then also, if you are a traveling HAB member, if you could get your travel information for October to Julie as soon as possible, that would be extremely helpful.
All right. Any other comments, announcements?
Oh, could I get a number of the people online, please?
Should we introduce ourselves?
I think so. We can do that too.
12 people online.
How many?
12 people online.
12 people online. Okay, again, I'm Rob Davis, chairman of this committee, and I'll be this for another year.
Ben Solis, alternate, Lori Hanford Cleanup Board. This will be my last official meeting. I'm gone September 30th, but I will be back in public matter member. Pleasure to be happy now.
That's right.
Tom Cecilia, State of Oregon, Oregon Department of Energy, I should say. I need more coffee today. I am, this will be my last Tank Waste Committee meeting as well because The other alternate for Oregon is going to be on the board October 1st, and he will be up here on the tanks, Matt Henderson. I believe he's on one there. He'll be taking over, or is the interim tanks member. So,
Welcome, Matt.
Rob Harmony, I'm the vice chair of Waste Tank.
G. Talbot, HAB Facilitation Team. For people on the line, we're going to be calling out your name, and if you could unmute your mic, you can just say the organization you're with.
Josh Patna, I support the HAB facilitation.
I'll be the command, the program manager for the large media, the presenter for various.
Steve Anderson, Grant Franklin County representative.
Susan Coleman, public at large. Marianne Monke, HMIS.
Lindsay Summers, COE, and Dan, thank you very much for your service to the HAB.
Chris Sutton, public at large, and chairman of the BCC for 2 more weeks.
Pam Larson, I represent Benton County. We're going to miss you.
Tom Rogers, Washington State Department of Health.
Thank you. And online, Patrick Conrad, Bonnie Gabe, Dana Gribble, Matt Hendrickson from Oregon Department of Energy, Lee Wan, Liz Matson, Joe Lucas, Dana McFadden, Mia Burke, Jacob Reynolds, and Rose Ferry. And with that, I believe we are ready to start with our first presentation. Also, because we're recording, you can speak a little louder and just a tad slower. That's what we ask for our presenters. Thank you.
So I can do the presentation from here, sitting?
Or you can stand up.
Either one, yeah.
Doesn't matter.
just make sure you talk to the owls.
Okay.
I got to be back a minute ago, and he said he's been with the DOE for 4 years now.
Yes, over here is fine?
Whatever works best for you.
Okay, so, yeah, good morning, everyone. So my name is Vivek Kama. I'm the program manager for liquid waste processing facility, which includes the ETF, the effluent treatment facility, and the LURT, which is liquid effluent retention facility.
And Vivek, if you could just wait a second until the facilitator could bring your briefing on screen. I need a one right in front of you.
All right, we're set. All right.
Yeah, next slide. So the purpose of the briefing is to inform the HAB members on the recent upgrades we completed the LURT and ETF in order to support the direct renewable activities, those with the DFR program. So what do we want from the HAB members? This one is, this presentation or this briefing is only for information purpose only, so no advice is requested. Next slide.
Yes, and if you could perhaps step closer to the table, people are online are having a hard time hearing.
Okay.
Standing here, yeah.
Yeah, thank you.
So I believe like many of you have already seen this slide or like this graphics. It shows a day in the life of direct field activity waste operations as shown in the picture. There are like over 25 unique operations taking place at the same time on a daily basis to support the DFL operations. And the LURT and ETF roles comes at the very last stage in the waste cleaning during the DFL process. I know it's very hard to see, but if you focus on the top right corner, you'll see the LURT and the ETF. As you can see, it says like we're expecting to receive around like 45,000 to 95,000 gallons of liquid waste from WTPMF once or twice per week. So that will total around like 4 to 5 million gallons a year.
And Vivek, maybe if you stand here, you can put your back to me, but that way your voice will be going towards this.
Okay.
Here, you can stand right in front of me, because I'm looking at my computer. Perfect. Yeah, it's like setting the movie stage. All right, go ahead.
So the mission of alert and ETF is to, as it says, like store, treat, and dispose the secondary liquid waste we receive from the WTP EMF, like effluent management facility during the DFLO operations. So the LERP is basically a detention facility, like its name says, and it stores the liquid waste that will be received from the WTP EMF and also from other Hanford waste generators. And the ETF, effluent treatment facility, is basically a wastewater treatment plant, and it treats the waste received from the LERP and also disposes it too. Next slide. So this slide shows the recent upgrade we did at the LERP, or the liquid effluent detention facility. As shown on the top left picture is the construction of the basin 41, our fourth basin. And we started that construction of basin 41 in July of 2021, and by the September of 2022, here you can see we completed the construction. And the right one is the aerial picture of the LERP. As you can see, there are 4 basins. The very left is the basin 41, our newly constructed one. And each basin has a storage capacity of 7.8 million gallons. So with the 4 basins in hand, so the LERP has total storage capacity of around like 32 million gallons. Next slide. So this slide shows the recent upgrade we did at the loading building at the ETF. So we not only receive the waste in transfer line at LERP, but also we receive the waste in totes and tankers. And the loading building is where we receive that waste, liquid waste in totes and tankers. And the very picture on the top left is our recently upgraded main loading building. So our previous loading building was only able to process 1 tanker at a time, and it wasn't able to accommodate or like fit in the whole tanker inside. So which was like a restricting like the operations during the winter months. So what we basically did was like we extended the building footprint so that 2 trailers, 2 tankers can be fitting at the same time and unloaded at the same time. And the bottom one is the backup loading building. We recently constructed that one too. So as its name says, it's a backup in case our main loading building is down due for maintenance, or like we have any operational issues, then we're going to use this backup building for loading of the liquid waste. And on the right side is the loading platform that's installed inside these 2 buildings. As you can see, it has a loading arm that will be used to pump out the liquid from the tankers and the totes. Along with that loading arm, it has some filtration system, the pumps, and other like instrumentation that will support the loading activities. Next slide. So this slide shows the recent upgrade we completed at the main treatment train inside the ETF process flow. So ETF process flow is divided or like categorized into 2 treatment trains. So the main treatment train basically contains the processing units that will treat or destroy the organics and the radioactive components in the waste. Whereas the secondary treatment train, the STT, basically reduce the volume of the liquid waste that's received from the NTT. It basically evaporates the water that's present in the waste and reduce the volume. So the very first picture on the top left is our recently installed influent filtration system. So our previous filtration system was restricting the ETF throughput by requiring frequent maintenance because of the frequent cleaning and the flushing that was needed for the old filter. So we installed a new filter, and this filter has what is that called, ultrasonic transducers. It kind of like vibrates at a very high frequency, and it removes the solids that's attached to the filter. And all the solids that's removed from the filter will be collected on that vessel that stainless steel vessel at the bottom of the vessels, and we'll use the rectification water to flush it down to the secondary treatment stream. And the second one we have is our like carbon dioxide removal system. So WTP EMF secondary liquid waste we're expecting to receive during the DFO operations is expected to have a little higher concentration of soluble carbonates. So, and the carbonates or the carbon dioxide has a tendency to cause fouling on the piping and damage the downstream like processing units. So we're going to use this newly installed system and remove those excess carbonates. And also, so the system is installed in such a way that when we're not using the WTP waste, we can bypass the system and just do our operation without using that. So it's just for the WTP waste. That's what we installed. And the next one is the vessel logging system of the VOG system. So our old VOG system was again getting old and it was leaking and requiring regular maintenance. So we installed a new VOG system too, so we can cut down the maintenance time. And also we recently installed a few tanks and vessels to support the treatment of the DFO waste. So these VOG systems will be able to ventilate the oil gas that's or the fumes produced from those tanks and vessels during the operations. Next slide. So along with the system upgrades, we also did some power upgrades, electric power upgrades at the ETF. As you can see, there are like few transformers that was installed at the ETF. So this new transformer will provide the powers to our newly installed processing units or the equipments that will be used to treat the DFO secondary waste. Not only by providing power to the newly installed equipment, it will also provide power if we need in future for our future equipment that might need to be installed to support the ETF operations. Next one. Yeah. So this slide shows the recent upgrade we completed at the ETF to remove the acetonitrile or the organics present in the WTP waste. The very left we use our steam steeper and the concentrator column for the towers. So these towers has a packed bed inside. So the preheated feed will be poured down from the top of the towers, whereas in a countercurrent flow to the saturated steam or the hard steam that will be provided from the bottom of the towers. And the packed bed inside this tower will help to remove that organic or the acetonitrile from the waste. And the bottom right picture that shows the skid containing the pumps, boilers, and the tanks to support this acetonitrile removal system. And the top one is our newly installed chiller system. So this chiller system will provide the chilled water or glycol, that's what we're using, to cool down the condensate coming out from the towers and can be stored on the distillate tanks. Next one. So this slide shows the recent upgrade we did to store and load out the acetonitrile that's removed from the waste. So the very left picture shows the two acetonitrile distillate storage tanks, and each tank has a capacity of around like 25,000 gallons. So once the condensate or the condensate coming from the tower is cooled down, it will be stored in these two tanks. And on the top right, you see the distillate loadout building, and inside that building, it has a ventilated fume booth with a tote filling assembly, and inside that fume booth will use a 350 gallons stainless steel tote and fill the distillate. So the distillate collected in this tank will be poured inside that fume booth in that stainless steel totes. Then once the totes are filled, then it will be stored in that storage container shown on the bottom. So, and that storage container has a capacity to store like 24 totes at a time. So like it will be stored until we send it outside for the treatment. So, so the key takeaway here is like liquid waste processing facility, like I mentioned, is the very last step in the waste processing. during the DFL operations. And in order for LERC and ETF to support DFL mission, it needed major upgrades. And we recently completed all that upgrades, and we are currently testing the systems. And with that one, with these upgrades, we have doubled the processing capacity of the LERC and ETF, and we are in process of receiving the segregated waste from the DFL from someone. So, next slide. Well, I guess that's the end of my presentation.
All right, and after the presentation, we have agency perspectives. Who will be providing the perspectives for ecology? Do we have anyone online?
I saw Dana McFadden was online.
Dana, are you there? Do we have EPA online for the EPA perspective? Okay, we'll try and get Dana, we'll try to connect with Dana and maybe come back to this. Let's take questions or comments in the room.
I have one thing, point. They should be here. Okay, and they're not here, and we need their opinions. And so can you convey to them how disappointed we are that they're not here and we don't have them giving us their opinion of this? I mean, this is important.
I'll share your feedback with
Yeah,
with the
I
group.
think it's important.
Absolutely. Thank you, Rob.
Okay, I will lead off some of the questions. It's kind of curious. I don't see any radiation protection signs anywhere in these facilities here. This is pretty clean stuff you're dealing with, correct? What is the radioactivity of your feed? Or is it? I mean, it just seems like that's water we're dealing with.
So we might have a little radioactive components in the waste, but inside the ETF, we had the RO, the reverse osmosis filtration system, and the UVS, the ultraviolet oxidation system, and the ion exchange polyester column. So pretty much by the time the waste coming from the LERC leads to those processing units, it will pretty much clean all the radioactive components. So, and so basically the water coming out at the other end of the ETF is very clean water.
Right, right. So all the water going in the ponds is essentially no radioactive materials.
There might be radioactive, but very at the, I really don't know the concentration.
Very
but
small.
Very at a very small concentration.
And so that means all the maintenance here is all hands-on maintenance.
So the ETF has a control room, and like this is like a centralized control, like computer system. It's kind of like remotely control the valves and things, but there are like few valves that might need like manual
Right.
effort, but
Reach rods.
yeah,
things like that.
but like this, we are monitoring control system has that ETF monitoring control system has that ability to control those valves and control those flows remotely too. So this I would say is mixed, kind of like manual and automated.
The last question I had is that the load-in platform, load-in station, you talked about loading in and out.
Mhm.
So that means that you also load trucks to go out and they go to the ponds and fill
No.
the ponds, or where do they go? When
Oh
they
yeah,
load out?
so when the tankers come at the loading building,
Right,
then like from the loading building, we pump it out to the LERC. So
right.
it goes to the LERC. So it doesn't go back in the tanker. So we empty out the
Okay.
tanker and the liquid goes to the pump, goes to the LERC.
One way, okay,
Yeah.
thank you.
All right, we have, Tom, were you gonna report and ask question?
Oh, 1 second. Phoebe, did you want to take a seat for questions, or do you want to?
It's up to you, wherever you're comfortable.
Well, yeah, let's just stand there.
Okay.
So Matt asked the same question I was gonna ask, so
Okay,
when I'm in queue,
all right, so Matt, and then over to Chris, and then over to Pam. So, Yes.
You got it behind you.
So am I not in queue then? Is that?
Yeah, no, well, no, okay, so Tom,
Okay, sure.
and then Chris, and then Matt, if it's still relevant, and then Pam, Dan, okay,
All right. I have two questions and one of them Matt also put in chat, but,
okay.
so the first one is when you're, processing this, we know now that the throughput is greater because the upgrades to the treatment system, that's awesome. Is there a restriction as to how much you can release, as part of the injection permit? And what is like what assurance is there that is it tested in batches before it goes out, or just assume that?
Yes, so when we process any liquid waste that's coming into the ATF, then it goes through all those, the processing components I use, like UBRs and connections and auto system. Then the end one is the clean water, what we call, and it's stored in 3 tanks, like 750,000 gallon verification tanks. So it has a process, like one is receiver tank, one is holding, and we are like, and before we release it to the source, like the state of and disposal site, the water will be tested and like in the lab, and once it's verified, then only we will release it to the environment. So yeah, so it will be hold on those verification tanks before we release it to the environment.
Okay, and then the second question that Matt also put in, so you have the big holding cell for the distillate.
Yes.
What happens to that distillate? Is there a disposition, or does it get reprocessed and separated and purified and reused, or how does that work?
So like I was saying in the presentation, so we have 2 distillate tanks, and then we have that load out system with the fume, regulated fuel boom, it goes into that code 350,000 gallon store. So I guess our current path forward is like, we have a contract we established with the Thermo Fix or some other vendors. It will be sent out in quotes and like processed in the offsite. It won't be like processing section. It will be solidified or ground or some kind of like treatment will be done, and it will come back into Hanford at the IDA.
Okay, so it's normal disposition pathway for industrial waste, but it ends up at IDA. Okay.
And that's a question you and Matt both
Yes.
have, right? Okay, very good. Chris, and then Matt is withdrawn, and it'll be Dan and Pam.
I have 2 questions. How much acetonitrile do you anticipate recovering per day of, let's say, standard operations? 5 gallons, 10 gallons, 100 gallons?
I really don't know in the gallons, but the things so our treatment process works is like, we're expecting that when we receive the waste from the WTP, the organics in the WTP waste is expected to have around like 59 parts per million, 59 ppm of the acetonitrile in the waste. So when that waste goes through all our processing units and the towers there, when we do the steam stripping process, the clean water that's coming from the bottom of the concentrated tower has the concentration of 1.2 ppm. So from 60 ppm, we're gonna reduce it to the 1.2, less than 1.2 ppm. So it's really efficient. So there's really low concentration, but the tank where the acetonitrile distillate will be holding, it will have the 2.4 weight percentage of the acetonitrile concentration. So that would be around like 24,000 parts per million. The whole 2 tanks concentration on those tanks of the acetonitrile will be 24,000 parts per million. So
Burke has a related question. So it goes into those tanks on the side of the building.
yes,
Where does it go once those tanks are filled?
like I was saying, it goes to the loadout building and it gets filled into those totes. Then we're gonna ship it outside for the grout or like some kind of like cementitious forms. Then solidify it, treat it, and then it comes back to the idea.
Maybe related to what Chris said, do you have a sense of how long it will take to fill up a tote? Ballpark?
So that tote is 350 gallons tote.
Yeah.
So I really don't know the time, kind of like what I think the 7 GPM. I really have to check on the flow rate at what rate and how long it's gonna take to fill one tote. But I guess we have like 25 totes in hand, so, and it will be kind of like sufficient enough to hold like to
Like maybe
provide enough storage for that 80 tank.
months, like relative scale, And if you can't say, then you can't say.
I have to follow up
Okay.
on with that one, because I didn't know how much can take.
Dan?
I have a question and a comment. The acetonitrile systems, how long from the time you discovered that you needed it to the time you got to the point you are now?
Sorry, can you repeat that question again? I didn't-
So there was a discovery that the acetonitrile was going to be a problem.
Yes,
So how long from the time of that discovery to the time that to now, to the systems you've got almost complete?
I guess like, when we received the WAC, like waste acceptance criteria, or like waste profile from the WTP, we saw that there was like this acetonitrile representing the waste, then I guess we did the modeling at the ETF and see like, what system we need to build, like how, I guess like it's long effort, like it's not recently discovered, because we already, the whole process to build the whole system, it took like 2-3 years, so,
Yeah.
so it should be long before that one, so when we get.
I think that's remarkable. I just want to make a comment. Remarkable. Congratulations to you in getting on top of this and doing such a fine job.
Well, again, it became necessary once they decided DFLAW.
Yes, so the DF law is vitrifying the waste, and
That's right.
I believe, we're using some kind of sugar or something, and during that vitrification process, using the sucrose and the acetonitrile is
Right.
formed, and that's why we need this whole thin super system.
Right.
You know, it's just, I think to document how you guys did this and present it to the rest of the group is a way to, it's just remarkable accomplishment, I think. Thank you.
And my apologies if I'm not getting the cue quite right, but if you'll bear with me. So Pam, Mia, back to Chris,
And Tom had one too.
and Tom. Thank you.
Thank you. So LERC has been significantly upgraded, but it was an existing facility. What was the stream of material that came to LERC historically before the waste treatment plant?
No, what was existing facility? We had 3 basins. We recently added 4th one. So like before that one, so the recently upgraded basin 41 is targeted to only receive the DFO waste, like in the WTP. So, but the other 3 basins, like our like primary source for the wastewater is the 242 evaporator. The condensate, that's the kind of like coming out from the 242 evaporator is our major source for the water that's holding the water.
Thank you.
And Pam, no, sorry, Mia.
Hi, yeah, thanks. The audio today, for whatever reason, it just sounds like you all are kind of underwater. So I'm having a terrible time understanding the questions and answers. And I just wanted to clarify, so the acetonitrile distillate will go off-site to be grouted and then disposed of at IDF, is that correct?
Yeah, that's the plan, yeah.
Okay, and then another clarification, so you were saying 24,000 parts per million per tote, is that correct as well?
Not per tote, that's the concentration that will be holding in the ADST tank. So the ADST tank is 25,000 gallons. So yeah, the concentration of the waste inside that tank will be around like 22.4 weight percentage, which is around like 24,000 parts per million. So.
And that's per tote?
Is that per tote?
It's in the tank.
It's in the tank, and the tank is 350 gallons. So the per tote is 350 gallons of acetonitrile with 24 weight percentage of the acetonitrile, I believe. Yeah, that's the right answer.
So we have Chris, Tom, Dan, Rob.
At the start of your presentation, if I understood you correctly, you indicated that the ETF could process up to 45 million gallons per year.
No, 4 to 5 million. So 4 to 5 million gallons is the expected waste volume we might receive from WTBEMF when the DFLAW program is operational. So
4 to 5 million.
yeah, 4 to 5.
Okay. Where is that treated water going to go? You might have said, but I didn't
So the
catch.
treated water, it goes to the salts. The state approved land disposal site is like few miles north of 200 West here, it's an open pond, like, so that's where it will be disposed, but this is clean water, so like I was mentioning earlier.
Evaporation.
Yeah, so so we hold the clean water in the tank, we sample it, and if the concentration is right, then only we release it to the environment, so it's a very clean water.
Okay.
And that's permitted by ecology.
That's primarily ecology.
Okay, Tom,
I was just, 50 or 60 parts per million, that's like free-phase product, right? That's like an apple, is that, are you expecting a two-phase liquid coming in?
Sorry, I really didn't understand the question.
Well, it's nitrile,
Acetonitrile is pretty soluble
it
in
is,
water,
okay.
highly soluble.
I think I have a different model then perhaps. Okay, never mind then.
okay, Dan, Rob, and then back to Mia.
Could be a lot of solid secondary waste going to the IDF. Are they gonna redo the performance analysis, do you know? For the IDF once, and this is, a lot of this is very new. And the last performance analysis didn't take this, these solid secondary waste back into account. So are they gonna do another one?
Yeah, that might be the right question for the idea.
Okay.
For the manager, because it's not my area, so I really have
Get that on the record. Thank you.
knowledge in that area.
Rob,
Good. Good.
Okay. Coming in here and not knowing a whole lot of this process, it would have been helpful to have like a process flow diagram to see what comes in, where is it from, and what comes out and where those goes. That would have been handy. Let me try to understand. What goes out is the distillate, and then whatever's pulled out of the water to begin with. And if that stuff goes, it's gonna be maybe grouted, and
It's
then
not in there, so.
it goes someplace else. And the distillate, what's left is gonna go into these retention ponds.
So retention ponds is the receiver for the waste from the different
All right.
temperate sources.
But you said there's another,
Salts, yeah, that's the end of the pond, yeah. That's where the clean water will be, distributed.
okay.
What would you say that acronym again so everybody can hear it?
Is state approved land disposal site.
That's what salt.
Okay, and it's just another pond.
Yes, that's another one.
Because I thought at one time that the liquid effluent that's processed would be returned back into to be used in DFLAW.
Yes, so, if we have to use it, like, we need a liquid, we need the water for the different processes, yeah. So that clean water will be used in our, like, for the ETF operation, but the excess water will be discharged, that's what we think, so. Yes,
So we'll reuse it and only get rid of the excess.
yes.
Yeah, and reuse it.
Okay.
so the clean water discharge will be recovered and reused, and anything that is in excess of what's being reused goes to the salts area.
Okay, so how does that get back into DFLAW?
So I guess like, like I was mentioning, we have some filtration system, we need to do the flushing of the system, we need the water, we have a lot of boilers that need water too, so the verification water will be kind of like used for those boilers, and the flushing out needs to be done inside the ETF operation during the DFLAW mission, so that's how it's gonna be used. But we are currently using the verification water right now, so.
So once it goes to ETF, it doesn't leave ETF to go back to WTP. It stays there for reuse at ETF.
Oh, okay,
And the access will go to
Yeah.
the salts.
Excess.
okay, because I thought that whatever clean water was gonna be available would be returned back to DFLAW for its use there during that process.
Yeah, but the DFLAW, I mean, like, it's a program, yeah, but like, to support that program, we have to, ETF needs to operate. And I guess we can say directly that, so we are using that water inside the ETF during the DFLAW program, so it's supporting the water is supporting the DFLAW program, we can say that way.
All right,
Yeah, confusing.
Since ETF is a component of DF law, they're
Yes.
saying it's used within the DF law process, right? As opposed to other elements of.
Because because DF law uses water itself.
Yeah, there's other elements in DF law that we circulate before it goes to ETF. I think is.
Oh, yeah, oh, yeah. And probably one of the bigger volumes at a time is gonna be back flushing the transfer pipe.
Yeah.
I mean, that's miles long and, that 4 inches in diameter and it's gotta be flushed with, I don't know, 5,000-10,000 gallons of water. It can't be flushed forward into WTP, it has to be flushed back.
So that water goes to ETF.
Yeah, I guess like whatever, like, water is like, or the waste is coming from the pipes. So WTP is WTP EMF is connected with the transfer line, the two pipes, yeah, to the load, so. I'm not sure like what was your question, so the water, but if they have to flush it, then the water must be used from the WTP side to flush the waste down to the load pump, so that's the.
So that flush water for the transfer piping, it goes back into the pond, the retention pond?
So
It goes back through the treatment system because it potentially contaminates.
Right, no, I understand,
Yeah,
yeah.
it's just gotta go
Still
through
have
it rather than show.
Understanding the flow paths there.
So there's a request for then maybe a process flow diagram.
That's right.
That would be very helpful.
Yes, I took note of that.
Okay,
But that process for diagrams is in open public in the ETF, so our record permit. So is on the whole permitting, the process for diagram can be,
So it's available publicly
is
now?
available and for
Okay.
public.
And then we have Mia online and I will look for another round of comments. Dan, back to Dan, anybody else?
Yeah.
Okay.
Whatever.
Go ahead, Mia, open your mic.
Yeah, could you share the parts per million numbers anticipated before the acetonitrile goes through the system, and then in the tote, the parts per million numbers that are in the tote before it goes off-site?
Okay, so the parts per million numbers that goes from the to the Stinsper tower, the waste, when you say the feed to the Stinsper tower, the concentration of the acetonitrile on that feed is expected to be 59.9 ppm, around like 60 parts per million. Then when we do the stripping process, then the steam kind of absorbs all the acetonitrile and the clean water coming down, which goes to the verification tanks for the disposal of the salts. It will have the concentration of 1.2 ppm, less than 1.2 ppm. But the waste, the condensate that's collected that contains the acetonitrile and collected in the two big distillate storage tank, the 25,000 gallons one, it will have like 2.4 weight percentage of the acetonitrile. So we change that into parts per million, it's like 0.4,000 parts per million. So
In the two $25,000 tank,
yes.
25,000 gallons.
Yes.
All right, Dan.
On addressing the overall capacity, the system is designed to handle what the evaporator, the 242 evaporator, the low activity waste, and flushing the transfer lines.
Yes, that's,
Take care of all of that.
yeah, that's why we had to do this major upgrade, kind of like, we installed that carbon dioxide removal system, steam steeper systems,
So
then,
it's 2 melters.
well, I'm not sure, like, I think like when the fully operational, when we might be running 2 melters, but yeah, I guess that's the time, but I really don't know the WTP side, but what I know is like we are expected to receive 4 to 5 million gallons of liquid waste per year at Alert. And we usually like treat around like 4 million gallons per year. So the total volume we're gonna process per year gonna be 9 million. So that's from 4 millions we're processing at the current rate with the addition of 4 to 5 millions now, we're gonna have to process 9 million gallons. That's why I was saying we double the processing capacity with the addition of all these system.
And we'll also support because the VAP supports the transfer, the taking of the waste from the single shell tanks to the solid shell, double shell tanks, to support that. Also, at the current rate of doing that transfer from the single shells to the double shell.
No, I guess like that transfer mostly is supported by the evaporator. I guess that's on the evaporator side. So my area is just for the treating the waste received. So I really don't know like where the transfer is happening, where the water rate is happening. So
My question is you're gonna come back in another 5 to 10 years and say, we need to double the system. The whole process is just extremely water intensive. And there is some talk about doing dry mining and that might, I mean, this is very expensive. Oh.
yes,
Wait,
it's very, yeah, it's
not
very
that much
expensive.
water.
But I don't know what's in the future, but at the current rate, that's we are able to process whatever we actually
Sure, whatever
receive.
we do now, but 10 years, 5 years from now, we have to start all over again and continue to do the wet mining.
I'm sure about that. I have to check on that one.
Going back, people online, I think that we must have for internet is, can you clarify the parts per million going into ETF? Is it
60 parts per million.
60 parts per million going to ETF, 1.2 parts per million going into solids,
Yeah, it's into the verification tank, the clean water.
the clean water, and then 24,000 ppm going offsite to brine?
Yes.
Okay, so Liz, yes, you heard that right. And sorry, thanks Steve for reading, we just wanted to clarify that.
Oh, no problem. I'm just in interim storage. Do you have any concerns with capacity storage? You said that the totes, we have a limited number, 32. Do we have any
So
bottlenecks?
those stores are reusable. So once it sends to whatever the outside vendors, we're gonna dump that and it's gonna come back again. So it's a reusable tool. So it's not like one use only.
So as
So
long as we have a place to dump that?
yeah, I mean, whatever, like we have not dump it, like whenever we have to, I guess like whatever the outside vendor is able to process it and send the tour back, that we have so those are reusable. That's what I was trying to say. But it's not a one-time use only. So 22 tours or like 24 tours is good enough. So we did all this in the modeling. So we did a modeling, say like how many tours we need, like how many waste we need. So the modeling shows like the numbers for the tours. So it's not a random number we generated. Like it's based on the programming or calculations done by the computer system. So then we came with that numbers. Yeah.
My only was the concern that when the totes are empty, you having control or not having control of those, so you're not waiting or they're not
Yes.
available or the bottleneck, and
That's why we have 2 gallons, two 25,000 gallon tanks, because initially we were planning for only one, then we did the modeling and said like we might have some issues, that's why we doubled the number, so we have 50,000 gallon tanks. So that should be enough for like to hold the whole campaign worth of external waste in those 2 tanks.
Do you have a dedicated transporter for your totes?
I have to check on that one, so I guess like, I didn't remember the question, so I will follow up to them.
We'll get back to you, Rob.
Okay. So if the state would like to make a comment here on, give us some idea of where the documents might be found, where somebody could find the flow diagram, the other information. Is that?
Well,
I mean, we can provide you the full programs.
it's in the permit, right?
Yes, in the permit. Yes.
Okay.
all right, that's all questions we seem to have. Okay, go ahead, Rob.
In the, I don't remember the term you used, or the basin there where we put our clean water. The salts,
Yes.
salt.
Yes.
SALD.
Yes.
Okay, salt. I'm assuming that's permitted.
Yes.
Okay. Is there a limit on the parts per million of stuff coming in?
Yes, because since it's permitted, so I guess like, yeah, I mean, there should be certain numbers we have, that's why we do the testing, yes. When we were working on the institute, like the verification tanks, we send a sample to lab for testing and see all the components that needs to be like under the, whatever limits of college has like stated to us. And once it's meets the requirement, then we kind of like, and then when we do this, it's solved. Otherwise, we can, then I guess we have to reprocess it again.
Okay.
To meet that limit.
And the end result of that water is just evaporation into the.
Yes,
atmosphere.
or like, yeah, the evaporation rate on the groundwater.
If she's here, I'm not going to call it.
Okay, thank you very much. Appreciate it. Good presentation.
Yeah, I'm fine with it.
So with that, we really thank you for the presentation, for the slides, some follow-up materials that appear to be currently available in permit. Pull those materials so it's available for the committee members to get an overview of this. Thank you very much for your time and your presentation. And we are going to go to break, and we will be back at about 5 after. And if the next presenter is not here yet, we will take a later item and move it up.
Yeah, I would recommend, and Rob, if that's okay with you and Rob, to move up maybe committee business.
All right. So let them eat cake, as famous words.
That's right.
Oh, and Rob, so I guess I will need to bring your slide up, right? Open forum.
So are we going to start with the committee business, right?
Or
Or do you want to do a
open
forum?
forum?
Because
Well,
that
open
leads
forum is
right
gonna
into.
lead into it, right?
So
That
let's
could-
take a look at, and this is your meeting, Rob, so I'll defer to what you would prefer, Rob and Rob.
So notice that on the first couple pages, I put the work plan.
Say that one more time?
I put our work plan in the first
Or-
pages of
Let's,
my.
let's
That's
do
right.
that.
Okay.
And we're looking, Rob, as I take a look at the calendar, that the next Tank Waste Committee meeting, which will now be the Twist Committee, is January 9th. So if we could have some good dialogue as we go from committee business to open forum about the expectations and what type of briefings we're looking at,
Right.
that will be helpful for Mary Ann and I as we go back to build the briefings.
Okay. Can we make this on the full screen?
I'm slow but steady, okay?
She's stretching it.
This is going to Carmen. Carmen?
No, Twist. Twist,
Twist.
yes.
And I'm hoping that we just keep calling it tanks.
Well,
I'm gonna keep calling it tanks.
By all means.
I'll be bilingual.
I thought it said twist.
Okay, so basically, we have experienced in the last 4 years or so, DOE at its finest hours. They have been very open with us. We've got more information in the last 4 or 5 years from them than I can imagine, and I just hope this continues. And what I want to do for the new people, hopefully new people will be listening to some extent. But I hope you take a look at the website and take a look in particular under the Tank Waste Committee. And what you'll find is essentially all the meetings we've had for a very long time. I don't know how far it goes back, but I went back as far as 2019 and I started looking at the presentations. And we don't want to have repeat presentations here, but we want to have good presentations that discuss the issues that we're talking about each time. So in particular, and that's how our work plan is developed and generated. And so I just point out that we've had briefings on each one of these facilities in the tank waste or a joint meeting between with HAB, and then we also had a joint meeting with CARM or with RAP. But we've had briefings, detailed briefings on the tank farms, on the LAW facility, the TISCR, what we talked about the salt, ETF FLIRT. We had not too long ago a meeting on the transport. We've had presentations on all of these subjects, including the infrastructure and some of the things that they're having to do with that infrastructure. Next slide, please. So, our 2024 TWIST committee meetings currently scheduled. We have 4 meetings that we're going to be meeting at. And so I would encourage that when we have advice, that all of our members need to think about, can I turn this around in an email? Can I read that advice now and get my comments in so we don't waste a lot of time, soliciting. I want to solicit all kinds of input, but I'd like to be a little more efficient in some of our meetings. And so if we take it upon ourselves to make sure we read some of this stuff. But in our work plan for this year, we have basically a number of areas that we have asked people to look into. I've even taken a last meeting and even the Yakima meeting, I started a list and started talking to people and say, well, what about tank integrity do you want to know? What about low activity waste on site disposal do you want to know? And so I'm going to end the slides with basically a more detailed description of what I think presenters could present to us to give us more information. Okay, so we have direct feed, low activity waste briefings coming up. We're going to have tank integrity briefings. And if everybody remembers, the Karthik Subramanian and his people and Dusty were excellent presenters and a good update on that. And there are some reasons too. I'll point those out. System plan 10, we do need to think about this in the long term, and the DOE and ecology have this goal to get this system plan out. And so we need to make sure we allow time to take a look at that. The low activity waste offsite disposal, we've got a great start on that. I don't know if people feel that we've had enough information to maybe ask some more questions, more detail, or if people want to look at advice, let us know. Test bed initiative, we do need a lot more information on that, everything from the programmatic to the detail, a little bit more of the details of what we're doing. And I really think that the test bed initiative goes into the point that we've had FRDC, National Academy of Sciences, our own people here have done a tremendous amount of work what we should do with our low activity waste. And I encourage people to read them or read the briefs, because we really need to offer some advice on this. They have asked for public support for their decisions, and we need to be responsible for that. The second is, the last one here is the lesson learned from LAW to HLW. I think that's a really great starting point for towards the end of the year here of our year. We'll have a good starting point to push off the next, because I think that LAW will be into certainly operating one of the melters with waste in it. And then there was a request that we put together some advice on the grouting. And I don't think that you can totally separate grouting from where it's going to end up at. So be prepared. We're going to have some discussions on that, and we're going to like some good things. Next slide.
Can I
Yeah.
ask a question? Okay, so, test bed initiative phase 2 is 2,000 gallons, and it's going to Clive. It's not going to Texas. I know nothing about Clive. I think it'd be interesting to hear
Right.
something about
Right.
that.
Right. And go ahead.
Isn't it 1,000 gallons each? Or, yeah.
I know.
Someplace else I've never.
We don't know a lot about Clive.
Yeah, and that's one thing we need to have a little bit more information on the test bed initiative. I did find, and just for people, in the volume 3 of the FRDC report, one of them had a good detailed description of both those facilities, where they were, where they're positioned. Clyde in particular is in Utah. It's 1,000 feet between that and the water table, but DOE actually owns part of that disposal site. So they already are trucking things there, from totes to grout to other things. So, that's a really good thing from the standpoint of efficiencies. The thing about Texas is hungry, and they also have a very safe place to put the waste. And I think our biggest argument has got to be is, we're fine with it if it leaves Washington. We're fine. Okay, get it off the site. And I think that if our advice supports the FRDC conclusions, that will go a long way. I know TRIDEC and other organizations have been lobbying in Congress and other people and totally support it. That's one of the reasons why I'd really like to have an Advantech, Tracy, to come and talk to us a little bit, because I think the process, we're more comfortable with how the grouting is going to be done, and how what containers they're going to be in, and how they'll be stored and shipped and that sort of thing.
Rob, is FRDC the same thing as the National Academies study?
Yeah, so that Congress told the National Academies to go do something, and they allotted some money, and they called it a federally funded research activity or something of that sort, FRDC. And then they put together a team, mostly of Savannah River people, but there's also other consultants. And they studied the 14 different areas, and they had specialists. And I found that a lot of what they did was pretty credible. So I was really pleased.
Rob?
Yeah.
Quick question. We're gonna ship liquid waste to Clive, and they're gonna grout it on their facility, right? We're not gonna grout it here and ship grouted waste.
None of that's really determined yet, what exactly, but that is certainly one of the models that have been suggested, is liquid totes being shipped.
Test bed, I think that's.
Yeah. So, that will have more information with the test bed phase 2 to be able to say this.
Okay, so that one thing has not been determined.
That's right. I also think that, the other thing is, and I talked to Lindsay about this, and if folks remember, and I'll use this analogy, Al Kruger. Remember Al Kruger, everybody?
Yes.
Okay, very, very smart dude. Okay. He was our glass chemist for DOE, and in working with him over the years, I just totally trust him. Okay. So he gave a presentation, and prior to that presentation, we were all questioning whether or not we should take vitrified, the weir coming up for the vitrified LAW to be stored on the site, and how the weirs pass, of course, that we can. But at the time, it was all up in question. And when Al came in, Al gave us a discussion of glass, what it is, its performance parameters, where it's being used, where else in the world is being used, why is it acceptable, et cetera. We had a monumental shift in attitude with a lot of people that, gosh, it sounds like a pretty good plan, okay? And so we also need that with grout. We need some technical people to come in and talk to us about performance factors, how it's gonna leach, how it's gonna break down. What are the safeguards? What happens if we're wrong? All those questions we need to hear from the department or from their contractors. And in particular, some of the details of how grout binds up radioactive materials is, it's important for us to know this, I feel. Okay. So just working through, I'm going to go through and I got a few slides and I'm just going to talk about what I've highlighted here is in 2003, okay, we've had, when I was doing this, we've had 2 meetings, okay, and we had 4, or really 3 presentations, okay, and so a presentation to me is when DOE's communicating to us, when they're telling us what they're doing, and it's a great thing. So I basically summarized the years and taken a look at this, and in some cases, this was a very excellent set of presentations by Ricky Bang, and came in and talked to us about the successes of the cesium removal system. we did have questions in the audience, and he was able to answer a number of them. We worked on this meeting here, we didn't really have very many things, but we worked on our work group presentations from Tom over here, and that was very important in our priorities. Okay, so in 22, we had 3 meetings, and we had 2 presentations and 2 advice discussions. The 2 meetings were basically tank monitoring. This, honestly, I was very disappointed in this meeting because we had questions from the previous that were not answered, but the direct feed blood kidney waste and the cesium removal, that was an excellent presentation. Now, all these presentations are on our website, okay, and they're very thorough. They've been vetted by DOE, so please, people, go check these out. Some of them are just 2 pages and says what do they want, and that's it, okay? And you can either got to go to the audio if there is to really understand some of it, but many of them are like Alice was, I think, 60 slides or something. I got 32 slides and lots of good information. The advice that we talked about is one was the big thing is at this time frame is that we didn't see a lot of motion on handling single shell tank leaks, and so we wanted a response plan, and so that was basically our advice was to give us the response plan. Can you next slide? In 21, we had 5 meetings and 10 presentations and status updates. Very busy year. Tank integrity program. I believe this was the one Karthik was at, and so yeah, in 21, yes. This one in particular was quite interesting from the standpoint that we've been hearing about a lot of this development of new tools to investigate cracks and the structural integrity of the tanks and et cetera. We get a lot of that, oh, fancy robots and things, we're gonna do this and that. But now the results are coming in, okay? And some of the results are very scary, okay? And in particular, at the bottom of the tanks, we have what seems to be some stress cracking along wells and have problems there. And some of the single shell tanks are dome. Okay, the concrete dome is falling, exposed rebar, and corrosion. And so some of the things that I'm more interested in there, and that's just me as a former corrosion engineer and materials guy, is how long? How do we know how long that rebar is going to last? And we don't have that. And we're expecting maybe 50 years before we finally seal these things up, or a much longer time, and maybe the spalling would accelerate that. But I think that we need to be aware of that, and we need to follow it. So spalling was first found. They thought they found it in some fuzzy pictures back in 14, I think. And then in this meeting here, we got to actually see these pictures of area A, B, and C that really kind of, it does look like we should pay attention to that. How's that? Let's see. Again, we got more updates here. This was a very fun presentation here. This is our LAW. Once they put it in glass and in the container, they have to transport it over to the waste site. And so the discussion about this transporter, how it was built, what the pallets were, was very interesting. And I did correct DOE in that we saw a video last formal meeting where the video narrator implied that we were trucking liquid waste unsolidified across the site to the final barrel, and that's just not true. That's solid. It's kind of gets. So there's a big rotary pours spout, pours glass into the big containers, and then the elevator kind of moves it, loads another one, and loads another one. And these are offloaded into bogies. These bogies are taken to a cooling area, and all that is done with extreme care and caution within, the plant. And so those are solidified, they're solid, okay? So, yes,
I have a question on transporters. This past week, or maybe it's toward the end of last week, one of the what's happening at EM notices came out and had a little blurb on fritted glass being transported. Did you read that by any chance?
Yeah.
And it said that 350 containers are going to be transported off-site to be disposed of somewhere. And it showed a picture of the transporter with 3 cast iron, and it said that the transporters had to be specially manufactured. Are we paying for someone to specially manufacture transporters to haul that glass?
But what it was is that the pallet that those casts sit on have to be custom designed, okay? And that pallet rolls onto the flatbed truck, okay? And then the truck is then
But
transported.
not the flatbed truck has to be specially designed.
That's what there's not a lot they can do other than put another hold downs and make it more rigid and that, but,
Trailer has to be.
yeah, the trailer. Not
Or
specific
the
house.
trailer. Trailer, how to sit on, especially, you don't see those on the road.
And I'm speculating, but it could be that they needed to have highway-ready truck as opposed to just going to IDF and back. So they had to
Yeah,
have a
but
separate.
whether we're paying for those specially designed manufactured trucks, or whether you can buy them somewhere or rent them or lease them or what.
They've got them at Savannah River.
And I think they only have 3 here so far. And,
I don't know, but I wanted to just say, as time is of the essence, we have Becky here, so if you just wanna, you got about 5
sure.
minutes to wrap up and then,
sure, I can do that.
okay,
We'll come back to this one.
yeah, we can come back to that.
Yeah, and see, that's what this is for, is if you got questions, let's write those questions down and get them to Lindsay. And then she'll try to work with us and to figure out, get a present person here.
Yeah, it's really helpful for me to have those questions, and I know historically there were things called framing questions, which really helped build our briefings, and so if that's something that we could collaborate on, I think it would be helpful for all parties involved, especially when writing advice.
So anyway, let me just kind of close here, is that in 21, we were very busy, we had lots and lots of information. Slide up, please. And to 20, we had 12 presentations as well. Lots of detail, very good. But I find personally the presentations given by the actual people doing the work were always the best. And again, another slide, please. And in 19, we had 4 meetings and 12 presentations. So Lindsay, 12 presentations in a meeting. Can you do it?
Got big shoes to fill.
Yeah, I know. Next slide, please. Okay, so I'll close here is that when I went around to people's ears and I said, what do you want to hear? What is it important? And so I framed these such that I would hope that these could be blended into our work plan subjects. And I kind of put it in order of how they were listed in the work plan. Okay, and one is we need more tank information on single shell
Rob?
tanks. Yes.
Just a friendly process suggestion. If we look at this and the next slide, why don't we come back to this point here about that the presentations moving forward?
Okay.
Instead of working through this, like just do the high level overview here, and then we'll come back and do a deeper dive after.
Do
Does
you
that
want to
work?
go to the next slide?
Sure can. Thank you for that.
Okay. This next slide is one where we've been asked to offer some advice on certain things. And I think that with the FRDC, they gave us these criterias for helping us direct what we're going to do with our low activity waste. Long-term environmental safety effectiveness, implementation of schedule and risk, likelihood of mission completion, life cycle costs, security and regulation. The last one is public acceptance. If we are the public, I think that we have a responsibility to respond to this with either a letter from the main board or I don't know that advice is what it is, but I think that we should think about, trying to get our waste offsite. And if we can give a positive reflection of that to the academies, to the Congress, to people, that we maybe will get more action and moving forward, so. Okay, that's basically it. These will be on the website, right? This presentation. And so I'd like people to go through it. And especially this slide here, this has just got areas that I think that we would like to see presenters give us.
So, Rob, just on my part, thanks for doing the research, pulling together what's been presented, finding the work plan, and thinking about what presentations will be helpful going forward. We'll come back to visit this. Lindsay, anything to add?
Not this time.
All right.
Thank you.
And thank you for your flexibility and speaking now and coming back to it later. We really appreciate it. We're very efficient with the first item. Hi, Becky. Thank you for coming, and
And if you want to just come join us at the table, that would be great.
This is the problem.
Just sitting right here? Sure. All right.
if you give me a minute to bring up your slide and maybe just introduce yourself a bit.
Yeah, so sure. So while you're pulling up the slides, just to introduce myself to everybody, my name is Becky Blackwell. I've been with DOE for about 4.5 years now. So I came straight out of college as part of the recent grad program. My personal background is as a geologist. So kind of the scope that I help support here at DOE is as our tank farm closure program manager. So I get to oversee kind of development of our performance assessments, preparations for our closure plans, what we're going to do once we finish retrievals of all the single shell tanks. So one of those pieces, things that we do are the interim surface barriers. So what I was asked to come give you guys a status update today. So thanks for having me, and hopefully I won't be on the terrible presentation list, but I'll maybe make one of the decent ones, hopefully, being DOE and not the contractor. So with that, it looks like we can go ahead and start on the first slide. So what is being briefed today, I'm just going to give you guys a status update of our interim surface barrier program. What we've done to date, what we're currently working on, and what we have planned in the future. And this was just asked to be a status update. Definitely appreciate any questions. If I can't answer them here today, I'll definitely follow up and we'll get you guys the correct answers. So next slide. So as we all know, historical leaks in the tank farms have resulted in contamination in the soil. So that kind of continued. In many cases, I guess the contamination has not yet reached groundwater, right? So it's still there in that vadosome, which is that layer of soil above the groundwater. So it's really dependent on how much moisture is in that soil, as well as gravity, as to what's driving it down into the groundwater. So really the concept of the interim surface barrier was to minimize that surface water infiltration that would further drive those contaminations closer to the groundwater and delay that. So what we've done so far, DOE has started the interim surface barrier program. So it started with a demonstration, which was T barrier and TY barrier, which I'll talk about in the next couple of slides. And then once we finished that demonstration, it kind of proved and showed that the interim surface barriers were indeed effective in reducing the moisture underneath them and essentially around the tanks themselves. So then we went ahead and we constructed one at SX, TX, and then we're currently working on one at U Farm, which is going to finish any couple of weeks now. And then we've got two planned as part of the agreed order. We agreed to do one in B Farm, and then also we're going to replace the demonstration barrier in T Farm with a more robust asphalt barrier in T. So next slide. So this is our current barrier at T Farm. So this one was constructed and installed in 2008. So this one was kind of a demonstration project to try this new spray-on polyurea material that was sprayed over a geotextile membrane.
So it's the only barrier that doesn't cover the entire tank farm area. It's only kind of focused to cover a historical leak in the 70s from T106. So it was really aimed at minimizing the movement of that contamination underneath. So as you can see, well, going back still, we call it the taco. It's kind of that round orange shape, right? And then in the top left corner, you can see kind of that drainage ditch, and then kind of off screen up in the top there is an infiltration area. So essentially, that polyurea barrier collected all of the surface water, so that's our precipitation, our snow melt. With gravity, it's kind of sloped towards that infiltration area, so it goes across that drainage ditch and then into that infiltration area where there's clean soil, so that way, it's preventing that water from infiltrating where the contamination is and instead depositing it in a clean area. And, just a bit of historical, the tank farm is really that surface is gravel as part of the construction process for the tank farm, so it's very easy, for surface water to just infiltrate straight down. So this is kind of putting that impermeable layer over and delaying that movement and avoiding it altogether. So next slide. So the second half of the demonstration project was at TY, so this one was installed in 2010. And as you can see, we departed from that polyurea spray-on material. We had some lessons learned, turned out during the installation, it attracted radon. And it was also pretty slippery in inclement weather, so kind of a hazard for the workers that would be out there, because you can't walk on the surface. So we tried a new method, which we call MatCon, so it's a modified asphalt material. So we used that, it actually reduced the cost pretty significantly and was just a lot easier to apply. So that kind of became our path forward for the rest of the interim surface barriers to come. So similar thing here, the barrier is sloped, so that way gravity helps drain the moisture to a couple collection points, and then it's piped to an infiltration, or I guess in this case, an evapotranspiration basin. So it's an upgrade from the infiltration basin that we had at T-barrier, where now we create a lined basin, and then we have native plants and grasses across the surface, so it helps not only with evaporation of the water, but also transpiration from the plants themselves. So it's kind of off screen, so sorry I couldn't find a photo that showed both, but it will drain through some pipes over off this barrier into a basin area off to the side that we call an evapotranspiration basin. So next slide. So that was the completion of our demonstration, so we did the T and TY. And then, we sat down with ecology and said, hey, I think so far the monitoring data that we've collected, it shows that these are effective in reducing the moisture. So where should we go next? And we sat down and we kind of collaborated. We got a couple of priorities that we established into, what farms would benefit the most based on past spills and leaks, contamination. So the next ones that we decided would be SX, TX, and U. So we signed up to those through the TPA. So then SX was finished in 2019. Finished right before I started here. So I missed the construction of this one. But it was kind of installed, same material as TY. We used the MatCon. And then we also have the evapotranspiration basin that you can see at the top left. So that's got the native grasses there. It's kind of a combination of cheatgrass, bluegrass, wild rye, just a couple mix of native plants. So we usually construct the basin first. So we'll take about a year to construct that. And then the following year, we'll use that as construction for the barrier itself. So that way the basin is ready to accept that runoff water once the barrier is in place. So that's kind of the construction process there. So then next slide. So this was the first one that I was on, so TX barrier. Same thing, MatCon material, covers all of the single shell tanks in the farm. You can kind of see again in that top left corner, we've got another evapotranspiration basin over there. You can actually see in the top right, that's our old TY barrier. So the first MatCon. So you can see the color changes a little bit with age, but this is the fresh laid TX barrier right there. So same thing, use gravity, lessons learned from previous barriers. to minimize how much we have to cut and fill, to make things level, utilize gravity to the most extent possible to help reduce costs, but also make sure we're draining to those, we call them stormwater conveyance piping, so that way it drains into the basin. So the next slide, that's kind of where we've been, and this is our current state. So right now, we're working on construction of the U-Farm interim surface barrier. So last year, we finished the basin. So that's kind of that image on the left is our completed evapotranspiration basin. So that project went really well. And then the bottom right is a kind of a closer shot you can see from this summer where the native grasses have all been established, looking great. One of our lessons learned was kind of the timing of that seeding. So really want to plant it like late October, give the seeds a chance to germinate and then start growing in springtime. So I think that was a lesson learned from SX where they planted it in the summer, got too hot, had to re-go in and do it again. So lessons learned there. So that was last year. The next slide, current progress. So unfortunately, I had to make these slides a little bit early. So we're currently laying the asphalt as I speak. We're pretty much, I want to say like 60 to 75% laid. But these pictures are kind of that prep before the asphalt. So it's kind of just showing the contractors working. They compact the subgrade, then they put a layer of gravel down that they call the base course, and that's kind of in preparation and making sure everything's at the right elevation to support the asphalt itself going down and making sure that it's going to drain to those basin points. So you see the workers there. And like I said, they're laying the asphalt right now, so maybe I could follow up with more pictures, or you guys could always come out for a tour if you wanted to see it one day, the completed barrier itself. So next slide. And it looks like there's a hand up. Do you want me to take questions now?
Go ahead and finish because we've got Tom and Q and then Rose.
Okay. So basically, you know, key takeaways from this presentation really is that the interim surface barriers have been effective in limiting the infiltration of, you know, our surface water into the soils. You know, we've done both in-situ monitoring and manual monitoring, which is, you know, neutron logging. Our in-situ monitoring is heat dissipation units. So we've got a lot of data that we've collected that shows that the soils are definitely drying out underneath the barriers. So they have been effective in what they were designed to do. But it's really that they're kind of a tool in our complete toolbox in how we address and mitigate impacts to groundwater. So in addition to them, we consider things like our pump and treat program and stuff like that into, you know, what farms we want to hit next. But as mentioned before, U-Tank Farm, that barrier is going to be complete, actually a little bit ahead of schedule by the end of this month to meet our TPA milestone that we have at the end of October. So that'll be exciting, and hopefully we'll get Ecology to come out and take a look because they've got a couple of new engineers, so we want to get them up to speed on the barrier program as well. And then our next two, currently in the design phase, is the T barrier replacement. So we're going to go in, we're going to take out that polyurea taco. We're going to replace that with another modified asphalt surface barrier that's going to cover the entire farm instead of just over that leak from T106. So we got that, a design considerations report that we're finishing up right now. Then we'll take the next year to actually do the design. And then we have the design due to Ecology around the end of 2025. And then they'll review, approve, then we'll go in and construct most likely the evapotranspiration basin first for about a year, and then the barrier itself the following year. And then our AO milestone is for the end of 2028. So by the end of 2028, we'll have a replaced barrier at T Farm. Same thing with E Farm. The design will be done around the end of 2026, and then the barrier will also be done at the end of 2028. So hopefully I'll be able to give you guys another update when we make some progress on the design of those. But I think that that's kind of where we're at today, where we plan to go. I know that Ecology is also asked to start talking about what farms we want to hit next. So we've got that conversation with them coming up in maybe the next month. So I don't think Jeff Wine could join today, but we'll be having those discussions here shortly. So,
We're gonna go into questions, but Ron, is the presentation gonna pass for Ron? Okay,
I
so
feel like I should have added more slides after hearing your discussion. And Judy, can you confirm that ecology and EPA, no one had the, or they didn't have time for the opportunity to join?
great, thank you, Lindsay. So Dana, are you online and able to provide a perspective from ecology?
I am online, but no, I don't have a perspective. I found the presentation very enjoyable though, and I love the pictures. Thank you.
All right, thank you, Lindsay. And then, is EPA on the line at all? All right, Tom, to you.
Thank you, that was awesome. Couple questions. It looks like TY is showing some age and some cracking, settling. How much upkeep and does it need to get repaved, and if so, how often, that type of thing? And then second question is, looks like they're very rectangular in the tanks or not. So how do you choose how much overlap to have so you don't have, so your umbrella is big enough?
So first question, we have a maintenance performance monitoring plan that we have approved by ecology. So that kind of details what we do for our maintenance and monitoring. So we go out quarterly and we do kind of visual observation. We have a crew that goes out and looks, is the barrier still looking, does it have any cracks? Are there any penetrations? Is there any tumbleweeds that are filling up in the basin? Sometimes that happens, that needs to be removed, anything going on. So that gets reported on an annual basis. And then there's also parameters within the design and the technical requirements of the barrier, if it can still be functional with certain deficiencies that start to appear. So at this time, they're all still, even the T barrier itself is still functioning as designed, even though we know that it's got the cracks and it's got openings and we want to go in and replace it. So we kind of do that on an annual basis where we do our walk downs, our reviews of that. And then we meet with ecology, we go over that information and determine, is it still meeting kind of those design requirements that was intended, and it's kind of like a 95% of the surface has to be maintained. So then we would review in that meeting, do we think it needs any improvements? And at this time, TY is still functioning as designed and it's still definitely showing a decrease of moisture underneath, so it's been effective. So if something happens in the future, we would revisit if it starts to deteriorate at any point in time. They currently have a 25-year design life. So what was it? In 2010, we finished that one. So 2025, that would meet the end of its design life, but I don't think we're going to go out and remove it. Obviously it's still functioning. So we would want to leave it and then we would discuss, does it need any upgrades, updates, replacement, stuff like that. For your second question, I think I already forgot.
How do you choose how big to make the overlap?
The overlay. So I think it's about 25 feet away from one of the underground tanks. They modeled that to make sure that it would have enough edge cover. So that way, kind of if you envision it underground, that it would still kind of create enough edge over the edge of the tanks, right? Or whatever contamination is under them to make sure that it's efficient and decreasing that moisture. So they modeled it, determined what extent they needed it to go out past the tank itself. And it usually just kind of happens to be in that rectangle shape.
Okay, Rose. Go ahead and unmute, thank you.
Yeah, thank you. Okay, Rose Ferry with Yakima Nation. Tom had a couple of my questions, but didn't quite get all of it. One of the questions that I had was not only just, the overlap, but also the thickness of the barrier as well. I did notice some cracks and such too on a couple of the pictures. And so I was curious about the maintenance. I think you already took care of that, but I'm curious about the thickness. But the other thing that I'm really curious about is, I guess, the level of testing that was done to ensure that you had adequate overlap, because just to say, oh, well, we're just going to go 20 feet beyond the tanks, that should cover it. we know that there's been horizontal migration of contamination underneath those tanks. And so I guess I'm wondering, what level of testing that you did to ensure that you were encompassing all that you needed to encompass, number one. And then number two also is what level of testing was done to ensure that the basins that you're draining into, that you're using, do not have contamination below them. Again, kind of referring to known horizontal migration of contaminants.
Yeah, so to your first point, so I do want to make a clarification, I guess. So at least with T-barrier, where we do kind of see it pulling away from the edges of penetrations and things, and we do see that cracking, it doesn't actually extend all the way to the bottom. So you kind of brought up a good point in the thickness. So there still is a continuing barrier cover over the farm that hasn't been penetrated exactly by any of the cracking that you see.
What is the thickness? Do you have an approximate?
So the polyurea is a 1/4 inch thick of the polyurea, and then it's on top of a geotextile membrane, and I don't know the thickness of that, but I can get that for you. And then for the modified asphalt barriers, those are 4 inch thick. And then they're also over, like I mentioned, kind of a base course layer of gravel, and then they've also compacted soil as a compaction layer. So it's kind of a multi-layered, yeah.
So you have the compaction level.
So it's got the modified asphalt on top, 4 inches, and then underneath that is a compacted gravel layer called the base course, and then underneath that is the compacted soil itself, and then the tank farm.
Great. And so level of testing for?
To determine, so I definitely know we've got some engineering studies that were done, I believe by PNNL as part of that T&TY demonstration program. I can't remember it off the top of my head, but I can certainly follow up and get that information to you on how they determined kind of what that overlap needed to be, or I guess extension needed to be, to ensure that it covers the tank farms and reducing that moisture in the area. So sorry, I don't have that on my head, but.
So I guess what my question is not whether or not they did modeling or any of that. Did they actually do any physical boots on the ground testing to make sure that they were covering all of the contamination? And did they do boots on the ground testing of the the drainage basins to ensure that, so I'm not talking about modeling, I'm talking about, so if you're,
Like soil.
that's the question that I want answered is whether or not there was actual samples taken or something like that done to ensure.
So
soil profile.
2 pieces, I guess. So backing up on the barrier itself, we have monitoring nests that are measuring that moisture level in the soil. So we've got control nests that are outside the barrier footprint in the farm to give us the control data. They also had placed as part of that demonstration monitoring nests right on the edge of the barrier to be able to take those measurements as to whether it's extended far enough. And then they also have monitoring nests underneath the barrier itself. So by using kind of those monitoring nests right on the edge, that's how they were able to determine that, yes, it was drying effectively on the edges. Not as much, of course, as directly underneath the barrier itself, but enough to ensure that it was functioning as.
I think Rose is asking if there were any soil
The
profiles
second part.
taken,
Yeah.
not for moisture,
She's still
but to
answering.
make sure the contamination.
For the basin itself. Yes, so
Exactly,
the second part, so they kind of do an extensive review and looking at where all of our past contamination or with sites are. So it does go through kind of like a cultural, ecological NEPA review. And during that process, they determine where those areas of contamination are. And then they plan the design around that. So that's kind of something that we're working on with E-Farm, is determining where we're actually going to put that basin, because we do have a lot of with sites and contamination areas around that farm. So we have to make sure that we find a spot where it can fit. Also, as they're doing the construction itself, they are monitoring the soil to make sure that no contamination is, that wasn't anticipated, is come across, and then they have the response actions to stop work and ensure the safety of the workers when they're actually out there digging. So does that kind of answer the question?
Yes and no. I guess I was looking for a more in-depth type of sampling to ensure that if this is where all the water is being drained to, that there's no contamination underneath that that basin, the drainage basin. And so the question was really simple. Did they do any in-depth, soil profiling and looking for contamination? It's one thing just to look all around and say, oh gosh, yeah, we know we've got contamination here, but do you know for a fact you don't have contamination where the basin is? Did you do that type of analysis and soil profile testing?
Yeah, so I think I understand your question a little bit better. So I'll explain a little bit about the evapotranspiration basin itself more. It is a lined pond. So it's not the same as that T-barrier infiltration where the water is actually going in. So it's a lined pond and then it's filled with clean soil. So there's no potential for there to be any contamination, movement, or such underneath that evapotranspiration basin. And that water is only, disposed of through evaporation or transpiration. There is no infiltration of that into the soil below.
Thank you. That was the key component I think I was missing, was the fact that you did have a barrier from it going down.
At the end there.
What's that?
Sorry that it took me a while to figure out where you were going, but okay.
Yeah. I just wanted to make sure we weren't, just draining water into the ground that was going to be affecting contamination potentially below there. So that was the one little thing I was missing, is the fact that you're preventing that from happening. Thank you.
Okay, Steve and then Dan.
I guess in context of Rose's question, I was wondering, are you monitoring the borehole logs, the Vadal Zone activities, to seeing if there's any changes or alterations in the farm?
So in terms of all of our monitoring nests, we also installed boreholes at all those nests. So we go in and we do neutron logging in those to determine moisture.
So just moisture. So in terms of migration underneath in the Vadal zones, we have thousands of borehole logs. Do you guys look at that and reference those in any way?
Yeah, we do those under a separate process, so not really in our interim surface barrier program, but through kind of that RCRA facility investigation corrective measures study, where we address contaminated soils within the tank farms. So in those programs, we have direct push, where we go out, we do those soil investigations to determine the extent of contamination and make those decisions on how much do we need to clean up, where it is, stuff like that. So it is separate from the interim surface barrier program, where this is kind of a groundwater mitigation action, but we have separately where we do go in and we investigate the soil. They actually just did some work at one of the barriers, I can't remember, but I'll let you know, where we actually did direct push around the barrier, even though it's already installed. So it didn't prohibit us from going in and doing some analysis. I think it was at T-barrier, the taco. So they actually did some direct pushes through the barrier itself, later went in and repaired, but they were able to get that information from below the barrier.
As part of the test criteria. Along the lines of T-form, did it fail? Is that why you're replacing it?
No, it's still functioning as designed, so it's still functional, but we're kind of taking that opportunity as part of the agreed order. It was important to ecology that we replaced it to make sure that it kind of was that same functioning modified asphalt that the rest of the barriers were. So it is, of course, its 25-year design life is coming up, and we are wanting to kind of mitigate what's in T-Farm, and it had a lot of historical spills and everything there. So we want to replace that and put in a new one that's going to last another 25 years to give us some time to address contaminations, all over the site, right? So we have to prioritize. So it would give us another good 25 years down the road.
So ecology was pushing for the upgrade, saying.
Yeah, we agree, it's still functioning as designed, But we also acknowledge that, yes, for the future, we'll replace it and put in something that we know has been really effective, which is that modified asphalt.
And Rose, I just wanted to note that in response to Steve, there was also an answer to that middle question, that they do site characterization through boreholes in the direct push to see where exactly the contamination is and how wide, which relates to how big a footprint do you need on the barrier. So, all right, Dan.
Thank you.
Questions.
Yeah.
The geotech is membrane, is that like a generic name? Like the,
It's kind of a common thing used in the industry, a geotextile membrane. you know.
geotextile?
Yeah, it's
Okay, I found
basically
that. I
synthetic
didn't know
fiber,
geotech.
yeah, that they
So it's
use.
just off the shelf?
Yeah, it's kind of a common thing used for environmental protection.
I guess the other question I have is why not just do a line drain basin over the entire tank farm?
They actually looked at that in studies and determined that it would be more effective
More
to have the
effective.
barrier with the evapotranspiration basin on the side. But that was posed.
Okay.
I can share the study if you'd like to see it, but.
No, that's fine. And the other, this is kind of off subject, but waste management area C, what's going on there now? And do you have any plans, or do you know of any plans for the near future?
I know that currently, right now, we're negotiating with ecology on kind of our closure plans as part of the Rev 9 process. But that's kind of all I can speak to right now, is that we submitted the certified closure plans to ecology, so right now they're reviewing them, and we're kind of waiting to get their feedback on our closure plans.
Okay, thank you.
Scott? Or Chris?
This is just a curiosity question, but we just talked about modified asphalt. Do you know how it's being modified?
Not off the top of my
Because
head.
there's a lot
I
of
should
ways
have
to
included
modify
the
asphalt.
pictures, right?
Yeah.
But essentially it makes it almost completely impermeable. So it's not like the off the street, it's not like a road, asphalt. It's I want to say, I don't know if trademark is the right word, but it's called MatCon. And so I can kind of provide you with that formula that they use to develop it and how it makes it.
It's called what?
MatCon. So MAT and then CON is their trademark name for.
That was a final Jeopardy question.
And the EPA and environmental are okay with us spreading out all this toxic chemical over the topsoil? I mean, what are you doing with the taco? I mean, that's gotta be all hazardous material.
Yeah, that's gonna be part of the design phase, and they'll determine how they're gonna remove it and where it's gonna be disposed, so.
Bob?
First of all, thanks a lot for the presentation. It's been very informative. The one thing we do know is the asphalt's pretty viscous and it flows, and we have hot weather here. And so I'm sure you anticipate some level of distortion. But part of the way asphalt gets its properties of being water resistant is that it's compressed. And so can you describe a little bit about the installation process? And are you using big rollers, and do we have big asphalt machines rolling over, or is it done by shovel? Because you're getting, you said, a 4-inch thick final. So you're probably compressing that from a 6-inch to a 4-inch.
Yes.
So can you give us some more information there?
Yep, so they've got they've got the big truck that comes into the farm, they've got kind of a staging area off to the side. They then use kind of smaller little dump trucks, they'll drive them over, and they have a whole placement plan of like how efficient they can do it. So it's kind of in strips that they go across the proposed footprint. So then they'll come in, they'll pour that fresh MatCon down, and then we do have rollers. And then some of the crew does it by hand around, like tank farm risers and still things that we obviously don't want to cover, because we still got to go in and retrieve the tanks. So it's mostly those rollers, and then they also do some hand compression around those penetrating equipment.
The nozzle. So then, somebody mentioned hazardous chemicals, we're going to dispose of afterwards, but I think some of the questions that I have is for the safety of the tanks below. in that, you know, in some cases, 16 feet of dirt is still 16 feet of dirt, and you get stresses on those domes. And so, have we integrated anything into, I mean, are we aware of that, and we're trying to protect against it, and what are we doing to protect against it, and does Carthage know, and?
Yes, Carthage is definitely involved, so we do coordinate with our tank integrity as part of the design process for the barrier itself. We do dome loading calculations to ensure that everything that we're placing, the barrier, even, you know, the dump trucks that are driving over, all of that process is calculated in, so we make sure that we're not within that dome loading barrier kind of that we have, so.
Thank you.
Do we have other questions or comments? Anyone online? Mia, go ahead, open your mic.
Yeah, you mentioned that the closure plan for Sea Farm was submitted to Ecology and you're waiting for a response. I was wondering if that closure plan is going to be part of the Rev 9 permit coming out in early 2024.
Yep, that's what we submitted it for, so it's been part of that Rev 9 permit renewal. Yep.
Thank you.
Any other questions? Well, it sounds to me like you earned a gold star, and we'd like to invite you to have a piece of cake to celebrate.
I know I wasn't the contractor, but thanks for bearing with me.
All right. So thank you.
You work for DOE,
Yes,
and who's your boss?
Ricky Bang,
Oh, Ricky Bain, okay.
with the other good presentation.
Yeah, exactly, right?
Yes.
Yeah. I'm just.
He mentors them well.
Names and peoples and things of that sort.
Always invite geologists.
Yeah.
I'll take it, thanks. But yeah,
All right.
hopefully you guys can come out sometime if that's possible and take a look at them if interested. I have that noted.
Okay, thank you. Let me.
Thank you, Becky.
Thank you.
And you can't leave without getting a piece of cake.
Thank
I'm
you.
really trying to get rid of it.
Yeah.
Do we, is Roger Gordon joining us online or in the room? Do we know?
One more time.
Is Roger Gordon going to join us in the room?
He's gonna be here in person, but he is not here yet, so let's go back to
All right.
committee business.
We have, so just to recap, we've got about another half hour. So if we could go back to those slides, Rob, that you were working with.
Sure.
Or go into open forum, whichever.
Well, no, that's where we were. So,
We were kind of in.
yeah, we were in.
Okay.
Yeah.
I mean,
that's
yeah.
fine.
They're listed separately on the agenda.
Roger's here. All right. Let's just pause for a minute. Let's take a 5-minute break. Give Roger a chance to get settled. We'll pull up the slides and then we'll start with our presentation.
We've got your briefing too.
Thanks for your accommodating and flexibility in the schedule. We have Roger Gordon from DOE, who is going to provide an update on the commissioning status.
All right, good morning. So Roger Gordon, I work with ORP, Commissioning Maintenance Operations Director, under Matt Irwin, who's the acting assistant manager right now. So I'm here providing an update just on how we're doing with commissioning. Is that how you guys see it? All right, good. I brought some cool pictures too, so I like to use pictures a lot. So if you can't see them up there, I've got some handouts I can share as well, but they're, so the first one here is just basically I just wanted to kind of explain our schedule. Not really the actual detail of the schedule itself, but just the steps we're taking from where we are today to get to hot commissioning. So right now, today, the melter one is heated up. We're at 2100 degrees Fahrenheit. We've got a melt pool in there, 31 inches, which is way cool. And we're on joule heating. So we're getting ready to get into melter one checkout. And we're also kind of in parallel, we're working on preparations to start heating on melter 2 as well. So we're kind of like working on a number of things, which is, it's pretty nice. So the way the schedule's laid out is we've got the melter 1 heat up, which has been completed. And we're preparing for the checkout portion of it, which I'll get into more detail on a couple slides of what checkout means. And then after that, we'll bring up melter 2. And then we'll get that heated up. And then what we'll do is, this also allows the operations personnel, all the operators to get experience with operating both melters as well. And then while we're doing that, we need to bring our off-gas, components of our off-gas online. So like mostly on the secondary side. So like the carbon bed, the TCO, SCR, the scrubber, we'll get those online because right now they're all in bypass. And we'll get those, make sure they're functioning at temperature. And then what we're gonna do is then the contractor will get into a management assessment and to make sure they're ready to actually get into cold commissioning, which is where we actually bring a simulant. We'll simulate what the feed will be for the systems without bringing in hazards, right? So, and then after that, we'll get into the cold commissioning activity, and that'll be basically operating the melter and the off-gas system and everything with simulated feed. And then right after that, we'll do our environmental performance demonstration test, which is make sure we meet the permit requirements in the off-gas system so that what's going on the stack is what we anticipated, and that all the components are actually removing the constituents they're designed to remove so that it's working properly. And then after that, we'll get into a contractor will do their readiness review, and then DOE will come in behind and they'll do their readiness review. And then we get into hot ops. So we're looking at, I think the current schedule is June of 25 for actually initiating hot operations. So all these should be happening in between. I will say right now, we're anticipating November-ish for starting melter 2 heat up. And then cold commissioning activities, like that said, probably late winter, early spring. So that's kind of what I wanted to kind of discuss on this page here. Any questions or anything?
So this is conservative, what you just said.
Conservative? Yeah, so,
You'll meet these, no problem.
yeah, I mean, yeah, I think so.
Excellent.
Yeah. The schedule is, right now we've had, I don't know if we've had some power supply issues that we've been addressing. So it's kind of, this isn't the exact current schedule. This is like about a month or two old because things get frozen for the presentation. But yeah, November, melter 2, spring, CCMA.
Do you have a schedule question? Dan?
Sort of a schedule question. The simulants?
Yeah.
Are those hazardous, chemically hazardous in and of themselves?
Yeah, I can't tell you the specific constituents in the simulant, so, but it doesn't have the rad component and, you know, that you have from the tank waste, but it doesn't have a lot of the other chemical constituents that we use to evaluate the effectiveness of the off-gas the system to be able to, and also to, you know, to make it last.
Well, I guess my concerted question there, even the hope is that we had a big meeting at the public library, and I walked by the city hall and I see that piping off of Hanford is a demonstration of what's going on out here, and I'm wondering why not have a simulant glass container there to accompany that, let folks know what's out in IDF.
Oh.
Instead of trucking it off to Arlington.
Arlington, yeah, so all the glass, the frit now, when we start pouring, those containers go to Arlington, the simulant will go to Arlington, as you know. But yeah, it's a great question. I mean, I'd like to see one out front so we can all sign it, but.
Yeah.
I'm working on it.
I request one from Oregon too.
There you go.
I'm gonna suggest that we go back to the presentation
Yeah.
and pick up this lively discussion.
Okay,
Yeah.
we can talk offline.
Yeah.
Alrighty, so next page, so this is, I call this our mountain graphic. And so what this does, my eyes are old here, so this kind of demonstrates, it's similar to the last graph, but this really shows all our readiness activities that from today going forward that we'll have to go through to verify the people, the plant, the paper are ready to support cold commissioning and then hot commissioning. So today we're on melter 1 heat up resumption. So we resumed the heat up back in June. We added frit, we started adding frit in August. Today we're at 31 inches. We're completely on joule heat power supply. And the startup heaters, right now, the facility's in the process of getting ready to remove the 18, well, actually, we've only got 15 startup heaters in there. And we're gonna put in plugs to get into the checkout portion of Melter 1. So then for Melter 2, heat up that you see there, the contractor has an operational readiness checklist that they're using to verify that they're ready to heat up Melter 2. It's not as formal as like DOE order 425.1 for readiness of a nuclear facility, but it's a very structured and prepared way to make sure that they have the people, plant, paper ready to support Melter 2 heat up. And then following that, on the left-hand side, we have the emergency preparedness exercise that we'll be doing, and we'll be doing that to satisfy the formal readiness for the facility to make sure that they can effectively prepare and for an emergency, which would really, a big hazard out there will be ammonia. So anhydrous ammonia will be the one when we start bringing in. So we need to get this satisfied and the CCMA completed before we can actually bring ammonia on site and into the facility. And then the next readiness activity will be the coal commissioning management assessment that I discussed. That'll be, the contractor will be conducting it. The DOE operational readiness review team will be here on site observing it, because we'll actually be sort of evaluating their own assessment and taking credit for that. And then we'll implement our documented safety analysis, which is our nuclear permit requirements. We'll perform a verification review that they're ready and implemented. And then we'll be doing a very similar one for the RADCON management organization to make sure that RADCON's ready to receive RAD material as well. And then, like I said, then the contractor will do their readiness review, and then DOE will do theirs. Then we'll get into hot operations, bringing on feed from tank farms, which is way cool. So, any questions on this graphic?
I have one.
Yes, sir.
On your, let's say the DOE headquarters operational readiness review, is that going to look at, are all 25 of the subsystems operating in synchrony, or is it just going to concentrate on the melter area? In other words, there's a number of subsystems in this, and is your operational readiness review going to cover all of those, to make sure they're all a go? It's just going to concentrate on, like I said, on the melter area.
So it'll focus on the people, their training qualifications, procedures, the paper, the procedures, and the plant collectively. So, I mean, when I'm talking about the law facility, so yeah, we won't just look at the melter, we'll be looking at holistically. Is the facility, the management organization, are they ready to bring on feed?
But it's tied to the melter processes, so those people
Yeah, the melter,
involved with.
yep, and then the balance of facilities that support it.
Yeah.
Could you just remind us, why, when you started up the melter, originally you had to pause and take a look at what was going on, what was going on?
Yeah, so back, what was it, back last October, November, I think, is when we first started. We ran into an issue with the startup heater power supply. I can't get too technical because I don't speak electrical very well. I'm a mechanical engineer. But it's the power supplies, we had issues with the design of the power supplies, and we had to basically bring in new power supplies for the startup heaters. And we did that, and they worked great. And then we did an extended condition, and we said, well, hey, if we're looking at the startup heater power supplies, let's look at the joule heater power supply and the discharge chamber power supplies. And the discharge heaters, or the discharge chamber, they were fine. The joule heater power supplies, we saw commonalities in the issue, and so we upgraded those systems as well. So that was the main reason for the delay, was basically addressing those issues. And right now, I mean, their fuel heater right now is just purring like a kitty cat. It's really, they're doing really good.
Thank God you looked at both.
Yeah, I mean, the contractor on their own decide, hey, we need to go look all three, and that was a great idea.
And what is ammonia, what's its place in the process?
Ammonia is used in the TCO-SCR to help remove the NOx, and I forget the other constituent in the off-gas system. So it's used to remove one of the hazards in off-gas.
The SCO is, reduces organics,
Okay,
and the TCO reduces ammonia.
okay.
Thank you.
Yep.
All right, so on to melter one heat up.
Can I ask one question here, just to point out the schedule? So these, we designed these melters for 5-year lives. Okay, and we're spending 2 years on dead heat up on a melter, and that's 2 years out of its life. Question is there any way you can speed this up? Some of these reviews, hundreds of days. Okay, every one of those days, you're wearing more and more on that melter. And with a 5 to 7 year life, you know, we're taking valuable time out of that melter life doing paperwork.
So the clock started on the melter one when we initiated, resumed heat up. So that was probably June, this last June. So that starts our 5-year clock. And then as far as the schedule, the contractor's being very, I guess, purpose-driven. So they understand the pressure. And yeah, the melters are designed for 5 years. I mean, they were designed for that, but we could, the engineering will be evaluating and they may last longer. It's not like at 5 years we are going to remove them.
No, but I realize that we're chewing up their life.
Yep.
Okay, well, we might get 10 years or 12 years. Look at Savannah River, 12-year life on the last melter. But the other thing is we're still wearing it and we're not doing anything with it.
Better say sorry for the first one.
Well, being said is one thing, but these long delays for reviews, I mean, why aren't these people on site doing the reviews when they disclose? Anyway,
Well, it's a matter of just the facility getting ready for those as well, right? So we're bringing the systems online and we're getting the procedures online and then getting the people qualified to be able to operate it. So
Right.
it's a collective effort. I mean, I get what you're saying.
Okay.
And
I think that's point well taken, and
Yeah.
you have to do what you have to do.
And do you mind if I could make a recommendation? If we could just have Roger go through his slides, and we do have Dan McDonald on the line as well, and I want to ensure that the other agencies have the opportunity to provide their perspective,
Yeah.
and we can go into questions.
We started with the schedule question and we.
So we're just
Yeah.
going back the right direction.
Yeah.
All right. So this is, these are, I kind of modified these, but these are basically, what do I want to say? I call them like a placemat. It's a metric that the contractor uses on where they're at. So the top left picture is the picture of the melter. We've got 18 startup heaters. We energized them in June when we resumed heat up. So I look at these as like big toasters, basically. And it was initially we estimated about a 10-day process to heat up from ambient to 2100 degrees using these startup heaters.
I'm
And
sorry, how many days?
approximately
Yeah,
about 10 days.
about 10 days.
Yeah, it took almost 2 weeks. We had to do some software updates on the power supplies, but we anticipate 10 days because we do it so we don't induce brittle fracture on the refractory bricks and the melter. So we were doing like 300-degree lifts and then let it stabilize and then increase it. So. And then in parallel with that, we've got what we call jack bolts. This is the upper right picture. Jack bolts is basically to make sure that the refractory bricks, when it holds the melt pool, isn't putting undue stresses on it. So these jack bolts are spring loaded to kind of hold the refractory bricks in place. Lower left picture is then after we get to 2100 degrees, or after we did, we initiate frit, which we did in August, early August, and we pour frit up to 18 inches, and then that's our first lift, which we did with no issues. And then at that point, then we do our final jack bolt measurements, and then we we pull out 3 startup heaters, we put in 3 bubblers. And what these bubblers are is basically just, we use air, compressed air, to bubble the milk pool to mix it. And so right now we've got 3 bubblers in, and then after the 18 inches, we went up to 25 inches, then went to 31 inches. So that's where we're currently at. We're at 31 inches, 2100 degrees, and we've got 3 bubblers in there. And like I said, we're getting ready to pull out the other 15 startup heaters. We'll put in plugs. We may add 1 more bubbler. They haven't decided. And then we can get into the off-gas testing. So that was, I really wanted to kind of show with this picture, just to kind of explain what we've been doing during the summer. So it's good. So this one here is sort of the second half. This is when we do checkout. So now that we have the milk pool, we'll do 2 things. On the top, we'll be doing some pours. Each melter has 2 pour spouts, or 2 pour caves, so we can fill 2 containers at the same time. So we just want to verify that we can pour out of the both ends. So I call it LPH 1 and 2, east and west. I have to remember my alignment with the melter here. So that'll be coming up here pretty soon. But right now the contractor, what they want to do is get the off gas on first. So we're getting ready to put the plugs in, like I said, and then we'll start bringing on the components for the off gas system. And the main reason they want to do that is they really want to make sure the in leakage through the melter is within the criteria before starting up melter 2. So, so that's what I wanted to show with this one right here. And like I said, we're looking at bringing on melter 2 in November. So check out here. We'll start up. Hopefully they start pulling plugs today. It'll be today or tomorrow, and then we'll get into checkout or bringing in the off gas. So gives you an idea about how long the checkout's going to take. And then we also want to make sure that we can feed the melter after we can pour, using the process system, right? So that'll be another part of the checkout. We want to make sure we can feed it and then fill containers.
The time for that is 0.5. Oh, sorry, I'll shut up. Go ahead.
Go ahead, we're just gonna work through the presentation.
Okay,
Sorry.
so next slide. So again, I just like to bring cool pictures because for me, pictures are awesome. And everybody has hand up so you can see these better. So top left picture is a picture of the mezzanine looking over the melters. Actually, so you can see the melters up there. On the left, those are the top of the melters. The closest one is melter 2. The farthest one will be melter 1. Top right picture, when I talk about the startup heaters, all the cabling you see is for the 18 startup heaters in melter 1 lid. And so that's what we use to heat up the melter to 2100 degrees. So that's kind of like what it looks right now. There might be 3 less because we pulled out 3 of the startup heaters. So it's kind of neat because you can actually stand up there and it's ambient temperature, and you know the lid's about 3 or 4 feet thick, and then it's 2100 degrees below. But standing there, you wouldn't know it. So that's kind of cool, just to give you guys a reference for that. So the bottom left picture just shows a hopper. This one's sitting on top of melter 2, but this is the hopper that we use to feed the frit into the melter. So we used 2 of the removed 2 smaller plugs, and then we fed the frit, and the frit is really just glass beads that we use to fill. I think we used 77 bags, and they're like 5,000 pounds a piece, to give you an idea of how much frit. These melters are huge. So there's that. And then the picture on the bottom right, this is the melter 1 operator, and the gentleman on the right in the yellow is the commissioning test director. So this is, we're commissioning the melter still, right? We're still bringing them on, make sure everything operates right. So I just thought it was a picture worth sharing. This is in the control room. The commissioning test director and their operator, they've been there basically 24/7 since June. Not those 2, you know what I mean. And so yeah, so that's on good. And then the next picture here is So the picture on the left, this is a pour cave. This is actually the carousel on the bottom, right? And we can bring in, load in 3 containers right there. And then we've actually got you can see the elevator, and then there actually is a container right now on the left picture that is up against the pour spout for melter number 1.
Is this the pour spout up here?
Yes, the container right there where your arrow is, and the pour spout is right above it. So you imagine a container is about, I'll say 7-ish feet tall, and then give you an idea. And since we're talking about the pour spout, the picture on the bottom right is just a cool picture. So that is actually the pour spout, and this is the IR coming off of the, inside the discharge chamber, it's 2100 degrees. And what we had an issue with the elevator, so we had a plug installed. We just removed the plug to put the container back up before getting into raising the melt pool from 18 to 25 inches. So when they removed the plug, they took a picture of the pour spout, and it's like, this is a picture perfect. It's cool. At 2100 degrees, it's a lot of heat, but the workers, don't get wrong, the workers were protected. It wasn't that hot where they were at. So, and then again, the picture on the upper right is just the first bag of grid that we added. So that was sort of a big milestone for us. And that was back in August, I think it was August 2nd. It's 5,000. August 6th, yeah, 5,000.
So he had help.
Yeah, we've got big cranes in there, so yeah, he had help.
And do we have ecology on the line for perspective? Or that is the end, included, right?
Yeah, that's it. I was gonna open it up.
We go to agency perspective next. And is it Dan?
Good morning. This is Dan McDonald from Ecology. How are you all doing?
Great. We're missing Kate.
Could we start, please, with the schedule slide? That's the one I'm talking about. And Roger, thank you so much for all the information. I appreciate it. I do have a comment or two and a question. When you look at the schedule over the last 6 months or so, we've been in negative float for quite a while, and that negative float is continuing. So my first question is, where do you see on this schedule where you can begin to pull things back to the left? Do you have efficiencies or different kinds of things that you can consider? And that's just a general question at this point, but it kind of aligns with what Rob is saying. There seems to be a significant amount of administrative kinds of things that are being considered, and I'm wondering what you might be able to do to pull that back to the left.
So I guess the general statement is the contractor is, as we talk about bringing on Melter 1 and the Melter 1 checkout and then Melter 2, we're looking at things that we can slide left so that we're doing a lot of those in parallel. So that's one way they're trying to, recover some of this negative flow. I agree with the administrative, the reviews, the CCMA, that's the Coal Commissioning Management Assessment, the Process Safety System Safety Review, the COR, the ORR. One thing that DOE is doing is for our operational readiness review is instead of, what we're trying to do is take credit for a lot of these other ones, which will kind of help us move this to the left. So one thing that I've seen is as we heated up Melter 1, we've learned a lot about how the system operates, and we made some adjustments in it. We've made those same corrections or adjustments to Melter 2, so that when we bring Melter 2 up, we expect that it's going to be a little bit more smoother and hopefully save some time as well. So
part of the reason I asked the question, when you go into the consent decree space, COVID determination allowed 579 days extension, which puts us out to August, I think, of 25. At the rate you're going, if you can't pull to the left, if the negative float continues as it is now, you're going to blow past August.
Yeah, well, right now we're all confident we're not going to do that, but I get your point.
Okay, now to some specific stuff. Are you involved, Roger, in the issues that are going on now in tank farms with cesium and the extraction by the Tisker unit? The fact that they're not getting the extraction that they thought they would? If you are, can you comment on what you believe your side can do to help that problem?
I'm familiar with what's going on with your, I assume you're talking about with AP 106?
That's correct.
Yeah, I'm familiar with it, but I'm really not in a position to kind of discuss that. But I will say that WTP Engineering, they do have a team, like I'll call it a response team put together that is where WTP is involved in that. So I know WTP is supporting. I just don't have specifics. I can get it for you, but I don't have it right now.
No,
Yeah, Dan, I recommend that I'll take notes on any questions that you may have and follow up with the correct SME for that one.
all right, that would be fine. And then the other question I have really has to do with the GFR issues. Roger, I'm sure you're aware that the GFR system as originally designed is not working as we would hoped. Can you comment at all on the necessary changes that will be put in place to ensure that GFR works?
Clarify what GFR is first.
So GFR is our glass former system. It's basically in the balance of facilities, we have a GFR system. Basically, all these silos that hold the different strains of different glasses and silicas to be able to adjust feed to make good glass. So we've been having issues in that system with the augers binding up, the system binding up and not getting good flow. So we do have a good path forward. There was a team put together between ORP and WTP Engineering. And right now the path forward is we're looking to the vendor to provide us a mixed glass feed because it's not going to change for the first campaign. So for the first 1 million gallons, we know what the formula is going to be. So the vendor is going to provide it. So we're not going to depend on the GFR system itself to mix it because it can. And then with that, we've had some engineering team gone down to San Diego to the vendor, and they've made some design changes to the augers so that they can get better feed characteristics into the melter feed tanks. And so that's been done and tested. And so like phase 1, the vendors are going to provide our glass feed, the mix that we need. And then the second half, we're upgrading the augers in melter 2 auger, and then we'll swap over melter 1 to be able to feed from the hopper into the tanks. And then the third part is the redesigning the GFR system itself to I can get you the information, but basically make it a little bit more simple to be able to provide it so that the vendor doesn't have to. But
Okay, thank you. That completes my comments.
Nice, and there's a good fix going forward, but I can provide additional detail for you.
Okay, thank you. That completes my questions and comments.
Thank you. And do we have EPA on the call? So we have Tom. Are there others who have questions, comments? Dan, anyone else? We'll check again in a minute and online. There was a point of clarification that the glass bags are 300 pounds a bag. That's what.
Douglas Hendrickson is who?
Do we know, Doug Henderson? Can you just say who you're with? Or chat it? All right, so Tom.
Yeah, so I was just wondering, I guess back in August, they found some hexavalent chrome on a horsepower or something for the third edition. I'm wondering if that's something that's part of the process or where that might have come from, or if there's a.
It came out of the kind of, I don't want to say leach, but there's part of the refractory bricks contain the chromium. So as it's heated up, it's not, it didn't surprise them. It was, they did some research that they found the documentation that it was in there, so we already expected the chromium, but it kind of, I'll say, leached out of the bricks, and that's where it comes from, so.
So is that before the off-gas system is capturing it then? And
No, the off-gas is, well, it's already creating, it's operating, it's just not, the systems aren't even like to capture it, is what you're saying?
yeah.
I can't speak to that, but yeah, it didn't, the workers were protected because we had the off-gas on, so it was negative pressure. And then they adjusted the controls after they found it, so that mostly it's like the PPE requirements for handling the material. Because that really came off of the funnel for the hopper. The hopper has a piece of funnel that goes into the melter lid, and so when they pulled that out, that's where they found that a little bit of accident, that chromium.
And is the thought that that's just gonna happen every time there's a new melter startup, and then that'll be gone after X amount of time, or is it gonna continue to leach out?
You know, that's a good question, I don't know.
Yeah.
I don't know if it's a comment or a question. I worked in the parking plant 22 years. And
Which one?
22 years in the parking plant.
Oh,
Farmers
parking
and feeders and silos. I suggest you look around other industries to see how they solve their problems.
Yeah.
Otherwise, you're gonna have to put on another team just to keep those out running.
Yeah.
And keep these systems clear. It's a problem.
Chris?
In the picture you have here, you have an east and west discharge ports for the molten glass.
Yep.
Is the idea that when you're in full operations, will you discharge glass simultaneously out of those, or will it be one, then the other, and alternating?
It's my understanding you can do both at the same time, or you can do one. So you've got two melters, so we'll have 4 pour spouts, so we'll be able to fill 4 containers at once. But it's not a continuous fill, it's more of a lift each time using air pressure. And that's just to provide flexibility to be able to fill. We anticipate when we're fully operating that we'll be averaging about 3.5 containers a day will be the throughput through the melter. So we should be able to do them in parallel.
Okay.
Rob?
So, a couple of things to ask questions on. When we were building the lid, first of all, the melter assembly building was canceled out of the project. So we didn't have a way of firing the ceramic that we put in the lid of the melter, and it was a castable. And there was a lot of discussion on that. And so I know we put cameras in there. And so have we done camera inspections of the lid, the melter lid? And have satisfied ourselves that yes, this was a good thing to center in place versus we're got some problems.
I know we have some thermal cameras for the, to see filling of the containers. I'm not familiar with the camera, if we have cameras to actually look inside the melter while it's hot. I have to go look. I believe we have the ports, but I don't think we have cameras.
Okay.
Installed. But I can't, I have to go find out.
Okay, because that was a pretty decent concern for a long time. And that melter assembly building was in the hundreds of millions, I think. And so it was a cost-effective cancellation, but now we're dependent upon melter assemblies in, Utah or where else.
Yeah, so right now we have a facility just north of us in Richland, Atkins, I think it's their name. It's where Melter 3 is, right? Melter 3 will be delivered here this next spring, and they'll be assembled there.
Okay.
And I think Melter 4 will be the year after that will be Melter 4. So if the facility or the vendors in Utah, is it Provo, I believe? In Utah, I'll just say Utah.
It was Ogden.
And they'll be assembled just north of our offices in the Richland. I do know they're looking at another facility for HOW for those 2 melters.
Right.
So that's being evaluated. I just don't know. I haven't been too involved in HLW.
Okay. Yeah, but the company was
Peterson, that's it, yep. Yep, so.
Yeah.
I think I heard you say there's 4 pour spouts.
Yep.
So this committee has toured HLW from the beginning, and we saw 2 Lazy Susan systems, not 4.
So each melter has 2 Lazy Susans.
Right.
Yep, so there's 4 pour caves, 4 Lazy Susans, so melter. So I don't know, when you were there, when you saw it, it could have been that the doors were closed and they weren't open in the, but each melter has 2 pour caves, 2 Lazy Susans, so to speak.
Okay.
Yeah.
Which is this?
And so
Yes.
it's 2 melters
Yeah.
or,
1, 2, 3.
I guess we only went down the track for one,
I guess.
what's the word?
The bogies?
Runway.
One bogey track.
The bogies.
Yeah, we got a north and south line, so we've got 2 independent bogies. They can take a container to, again, for flexibility, so.
Okay.
So was there clarification on the weight of the volume of Brit? Is that what you said, Judy?
yeah, WRPS mission integration, Doug Hendrickson said that each bag weighs 300 pounds. Is that?
I thought they were more, they're big, but I could be wrong.
300 is a lot. It just, this, I was just, that didn't look like 5,000 pounds.
Oh,
Yeah, like here's the bag right here.
So one of the questions that came up, as soon as we saw the first picture of the matting frit into it, really last week. But frit has a connotation of silicosis, and it's dangerous and hazardous. And so if we're not really using a frit per se, we should quit that terminology. Yeah.
I can't speak to that. I know that everybody calls it frit, and our glass scientist Albert works up the hall, so he's familiar with it, so. I can go back and talk to him about that.
Fine.
Yeah.
Other questions, comments?
I guess I just had,
Oh, go ahead, Steve.
no, I just had one on the reference to the augers that we're talking about are the ones right here. That are-
No, the augers will be on the plus 48 level of the facility. Is we've got 2 big hoppers. We'll have augers up there to auger it down a big chute to the feed vessel.
So not in the melter to the.
No, that's just, that use just like a lift using air, compressed air to kind of lift the melt up.
Okay. Right. Or,
Yeah.
because I'm still not clear, where are these augers that are having issues with?
Oh,
But,
there's some in the GFR system itself and others upstairs in the hopper that holds the glass feed that will actually go into and we'll mix it with the feed from tank farms in the tank. So it's another part of the facility.
Oh, okay. So this doesn't have any waste in it, what you're saying?
This will, but these containers, this will be the actual molten. The augers will have the glass feed to mix with the waste before it goes into the melter and gets melted. That makes sense.
Yeah. Better.
And this is after the melt pool is mixed, the glass is mixed, then we'll pour it and then it'll cool and glassify in there.
So, I'm not sure if you can answer this one, but earlier we were talking about the new custom conveyance system to get the cold conditioning glass transported. And is that different than the conveyance system that would take the hot waste to IDF? And why is that needed?
I'm not positive. You say conveyance, you're talking about the trucks with the 3 containers in it? I think they're the same, but I have to go get that answer for you. I'll say I assume they're the same, but I'm not positive.
they're shielded, those containers on the truck. They have a pallet.
There's like a container they
And
sit
they open
inside.
up, you put the glass block in there, close it.
That might be the difference.
we'll follow up.
Yeah, thanks.
Rob, did you have another comment?
Well, I just want to point out that, that GFR system had been notably a problem from the very beginning. And a large part was the fact that it was a non-radiation system, and so it gave to a commercial supplier.
Yeah.
Okay, and a lot of those ingredients are air transferred, pneumatically transferred in there. And so these augers are way after that. Right.
Yeah.
But you can still get the blends, can't you? Into
Well,
the,
part of in the GFR and the silos themselves, they've been having, there's the augers, and without getting too specific, even in the silos at the bottom where they,
right.
they've been having issues there as well. So there's been the augers up in the hoppers, and then there's been the GFR in the, I don't know what I want to call them, I don't know the right word, but you know, at the bottom of the tank where they load and mix the blend, they're having issues with that as well.
Right.
And they still are. But you're right, the augers that up in the hopper, those, they have a good path forward for those. The design changes they're making to them, and that have been tested, and they works good.
And Mia's just clarifying that with the new mixed glass feed from the vendor, that you won't need the augers until later when the design changes have been implemented.
Yeah, they're gonna do melter 2 first, the hopper up there, so I don't know the exact schedule on how that works, but
But you've got
we have,
the mix coming in
yeah, we've got
to
our
give you
blended
time
mix
to
coming
do
in from the
it.
vendor, so that's like phase 1.
Okay. Mia, does that answer your question?
Yeah, thank you.
Other questions or comments?
Chris had one? No?
Anyone online? Dan?
This one is a long time ago, there was a discussion, I think it was a nuclear waste technical review board talking about what's going on in Savannah, and one of the comments that was made was the people supplying the glass made it in a solid form, and they chopped it up in the frit, and then shipped it off, and I guess what we're doing here is we're making glass beads and then shipping that off, so there's not that. That's how a block chicken got it, and to address the silicosis issue. So this really isn't frit, it's just glass beads, right?
Well, they call it FRID.
Well, that's tradition name.
Yeah, I know, it might be a traditional name, but it's glass beads, I can't tell you, I wish, if Albert was here, he could tell you the exact, and he's a chemist.
Just glass.
So I don't know how, I've never actually seen the glasses, so. Is that
Well-
something, would you like me to find out, is that?
Yeah, get something started on that. I had a conversation with Delmar Noy 4 years ago
Oh, okay,
about this very conveyance system because
Yeah.
of my history of particle work.
okay.
So Rob, is this another pass?
Yeah, we're good.
Okay, I mean on the presentation?
Oh, yeah.
Before you came in, there was,
I mean, like,
yeah, good job. So
Good
gold
job.
star, yes.
oh, yeah,
So thank you for this.
all right, thanks.
Thanks,
Yeah, call me
Roger.
anytime.
Thank you.
Yeah.
Do we want to power through till 12:30?
Yeah, do we?
Yes.
You mean finish it first?
Just,
Yeah.
hold it, we're gonna take 2 minutes to just discuss the agenda and the timing.
Lunch is scheduled for 12:30, so if we could power through, and because we already got a head start on committee business / open forum, I would recommend we push through it and complete at 12:30.
Perfect.
So
Does that work for the group?
Well, Rob and Rob.
Rob, gotta bring it back to the table.
Thank you for showing up.
Rick's over back when you're good.
So Rob, we are wondering if we can pick up where we left off on those 2 slides?
Sure.
And we can conclude at 12:30, that's, finish it up.
Sure.
We start happy hour way early.
Sure. I'm good.
That's the perfect time to get Portland to the 5 would be really great.
Oh, yeah.
Oh, yeah.
Your club.
Yeah, okay, sounds good. Okay, then, I think it's the second last slide. I just want to talk some more because those are items that I got from you, from the people of the committee. Because, like, I want to know more about this, I want to know more about that. And so, I may have embellished a few, added some details, but for the most part,
we make this larger for us old eyes? Since we don't have these in paper in front of us.
Yeah.
So I think that one of the things that we have in the tank integrity, which seems to be a repeating thing that we have taken responsibility for in this committee to really understand. And so we have seen these pictures of spalling and cracking and things of that sort. And this is what I think when we start looking at long-term projections for our site and without any final determinations on when we're gonna start retiring and doing something with the tanks, that's possibly 50 years. And so we would like really an update on the estimated life that we can expect out of these, or what are they doing to get the information to eventually tell us when the expected life is going to be. The second thing is they used to publish what we call the Easter egg chart, and now it has become a tank chart. But they have these charts where they show how much waste is in a tank and has all of them. And especially the ones that are designated as leakers. I believe that we as a committee here need to look at the big picture. And although the 170 or 160 some odd tanks, that we need to have a feeling of just, many of our discussions in the past have been this leak response plan. Okay, and we've got more tanks out there to leak. And we have approximately every couple of years, we get the word that, okay, we're finding something. And so I really think that we need to see that scorecard of how they're all doing, the big picture, and what can we do.
Great idea. I like that.
The other is that we really need this holistic presentation, this holistic site for our Rev 9 at some point. I know we're not ready yet, but possibly at the end of this year, we might be able to.
I don't have a timeline for you, but when there's something to bring to the board, I will let you know.
That's right.
It's on your wish list, at the very top.
I was gonna say, it doesn't necessarily have to be our committee, but I think maybe the whole board is very interested in this. Also, System Plan 10. I hope people's reading glasses are all clean and ready for it, because sooner or later, System Plan 10 is gonna come out, and it's gonna be thick and deep, and I think we're pretty much expected to take a look at it and possibly give comments to it. The next one
The
is.
scenarios for System Plan 10 have already been released and they've been out for some time. They're just the scenarios, they're not the complete document. So there's already some information publicly available.
So maybe in our executive issues committee, we then maybe divide and conquer on some of these scenarios between the various committees. Maybe.
System plans all things.
With that?
It's really a tank.
Yeah, system plans all things.
Yeah, that's a big, I know. Okay, try it. Okay, but the system plan is something we gotta keep on top of our heads, sooner or later, it's gonna hit us. The other thing is right now, we seem to be into this flexing stage here of FRDC reports, weird evaluations, B law versus S law. We have this stuff going on, and I think that we need to clarify this from that standpoint. And this all is aligned with the programmatic aspects of TBI. And so I really think that we should, we would love to have a presentation on the TBI talking about all the concerns that we've had here. We've had concerns about transportation, we've had concerns about what is the quality, we've had concerns about the safety of whoever if they send it off site, how do we know they're gonna be safe? So we have a need to understand a little bit more about the whole TBI, test bed initiative, the grouting process, and that aspect. And that brings us to this one here, is we need a detailed discussion on, or presentation on grout itself. And I will say this, and I said it again before, what Albert did for glass for us, giving us a very good understanding. We need somebody to tell us how grouts perform, how they leach, how well they tie up the materials. What are the different parameters of the acid, more acidic waste versus the more alkaline waste? We just need a lot more information on the chemistry, the pH, some of those kind of things, because I've heard from a number of folks that they don't trust grout, period. You know, they just don't want anything to do. They want everything vitrified or whatever. So I do feel that this committee should get a presentation, maybe two presentations or whatever, one big picture and maybe one more detailed. I don't know, but we want to offer some advice on grout. We need to feel we're empowered with the information to be able to offer it rather than, oh, by surprise, it's this. Well, we didn't know that. You know, and I hate having that happen. So, so grout is a real important subject here. That's why I have asked if we can maybe get a presentation from a DOE and then get Tracy from Advantech or that organization to, you know.
I have that noted.
I know, it's I think that would be real important for us to have a lot of confidence in the grout. And then we did have a question that you asked last time Pam asked last time about the Tisker waste or the orphan waste and what we're going to do with it. And basically, there's been a shift in what they're using for the beds to this CST, which is a crystalline silicon titanate. And it seems to be a material that's all inorganic, which would possibly be a feed for the high-level waste melter. So, and just so you know that I'm going back into Albert's last presentation, he actually presented a sign that said he really thought it could. And so I think what we need to know is that if that's our plan, is to take the CSTs and get them into the high-level waste, then into the high-level waste melter, then we should hear about it. We should understand it and understand why. I also went back another 20 years in a presentation, and just people should know that in the pre-treat facility of the WTP, there was two possible resins that they were going to use to extract the cesium. One was the sucralate, 644, and the second one was CST. Okay, and CST has gone through a number of experiments down San Brand River, but I do not know that the people up here either have that information or know about that information or can or cannot say that we're going to have a research program that says we're going to practice seeing if we can get the CST into a glass form or into the formula for high-level waste melting. So I think that that's an important thing to handle this whole issue of orphan waste. I think that's one thing that was called out a long time ago, is that we can't just leave waste here and there. We can't create lots of orphan waste when we're doing our work, and we want to make sure we're contained. And so those are basically 7, I think, 6. So those are basically the ones that when I polled everybody on the committee at one period of time, they thought that these were good questions to ask. And so that's why I present them this way. If you go very up the second slide, right there. So this is our work plan for this next year. We want to hit these topics. Well, we have identified in our work plan how we can get those. And I just hope that our presenters of these from either the DOE or ecology or whoever will take a look at what our needs are for these presentations. And so you can take a look at back and forth, and you see I kind of organize them such that they follow that order. And then this very last one. Last slide, please. The FFRDC had, actually, the National Academies had set the FFRDC on the project of what do we do with our SLA, what do we do with our, you know, in preparation for our weirs. They said the criteria that they were told to use by the National Academies included public acceptance. Okay, and I don't see anybody standing up in public saying, we accept it yet. And I think that we need to evaluate and say, you know, is this something we could write a letter of acceptance or a letter of support or a letter of, I don't know, the advice, but I would certainly love to have that discussion with people, what we want to do there. But I do think that we need to give the message to the National Academies that we are, first of all, in favor of isolating all that waste in a grout form. And two, we are, this is the SLA waste. We are also want it to be disposed of at a safest place that it can be disposed at. That safest place is not here on the Hanford site. We have 200 feet for the groundwater, where we have thousands of feet in the other two places that people have suggested that we send them to. And so we might take this opportunity to also highlight some of the unknowns that we don't know yet as being things that they have should be answered. But public acceptance is really what they're asking us. So that's kind of how I kind of tied in our request for this year with our work plan. And yeah, I think DOE is doing a great job right now. Going through these presentations, especially 2020, 2019, 2021, DOE is at its finest hour right now, meaning that they're sharing everything with us. I mean, there's really nothing that they are hiding. And so we need to make sure that we don't inflame for the unknowns. You know, but I don't think they're hiding stuff. I just think there's stuff they don't know. Okay, and this is 324 building. Okay, it's a perfect example. They just didn't know. They're not hiding. They're not being secretive about this waste. And so we've got a great working relationship now. They're going out of their ways to talk to us and tell us what's going on. Much progress is going on out there. And anyway, I'm real happy to be your chairman for the next year.
Thank you. And so, Rob, I will just say thank you for doing the research, pulling this together, organizing it, very concise, well presented. We have Pam, Mia, and then Tom, and then Dan, and Steve. Steve's already always last because I turn my head this way, but you're in queue. So, Pam.
So first of all, can you email this to us so we can all look at it?
Yes.
It'll be
Is it posted?
We post it potentially by the end of the day.
Okay.
Or email to us.
So, Rob, this is really spectacular analysis, but the reality is we get 3 meetings of this committee, right?
Four this year, we have 4.
All right. And have we already identified what we're going to develop advice on? Sort of. And one of it would be the grouting and shipping offsite is one topic that we would be providing advice on, right?
I think so.
That's what you're asking to provide advice on.
Asked to provide advice on. So we're not going to get everything that you would love to have. It's just physically not possible to address all of those in 4 meetings. So I think we need to prioritize. And I think we should prioritize the first one being the grouting, tank waste, and shipping it offsite. That'd be my suggestion. Thank you.
All right. Thank you. Mia.
Hi, yeah. So I have a couple of things to add, but just wanted to start by reiterating that Hanford Challenge and others on the board are not in favor of grout. And so just as a reminder that, letters of acceptance or an agreement, things like that, I think we're pretty far from that. And so just wanted to make sure that's clear. And so I also wanted to request that we get an update on how testing is going for the engineering controls for tank vapors. And that would be an update on the status and any setbacks or any effect to schedule. So I hope that can be brought to the committee. And then also, if they're like in one of these discussions about DF law, if it can be covered, the melter fire, and if someone can talk to that, that would be great. And I think that's it doesn't have to be a topic on its own. It can be wrapped into more discussion about DF law.
Did you get that? I only heard melter something.
So I heard that Mia and others on the board are not in favor of grout, and so there will be a lot of conversation, I believe, from that. Additionally, Mia is requesting an update on the testing for the controls for tank vapors, as well as addressing the melter fire for DF law.
Okay, thank you.
Mia, did I capture everything correctly?
Yeah, perfect. Thank you, Lindsay.
You're welcome. I'm taking notes.
Lindsay, this is Dan McDonald. I can talk to the melter fire in about 2 minutes.
Sure.
Let's hold off on.
So Dan is ecology, so we could just let Dan speak to that.
I had a clarification Dan will address.
Okay, thank you. Yeah.
Okay, essentially what occurred, there was a maintenance evolution that they were going to undertake in the pour spout. They put together a wooden jig to hold the parts. When they went ahead to execute, they recognized that the temperature on the upper part of the pour spout was a little hotter than they thought it was going to be. The jig itself was made out of wood. It was part of the evolution. As the evolution continued, the pieces of wood caught fire. The fire was self-extinguished in less than 5 minutes. The fire department was out there and checked. Nobody was in the area, and everything was all good. So this was not something that the techs took on themselves. This was a planned evolution. The one part of the construction pieces was just a little hotter than they thought it was going to be, and that was the end of it.
Mia, does that address your need?
Yeah, thank you.
Thank you, Dan. Dan, does that address what you were going to say?
No, I'm
okay,
separate.
That's fine.
Yeah.
Okay, good. So Tom, Dan, Steve, and Chris.
So I think I would really like to see a talk about the science of grout, and I think that is, before we talk about advice, that's what we should get. I think knowing that grout is a sticky subject, the board has a way to handle sticky subjects and also take care of number 6, and that would be a sounding board where every stakeholder and public member and tribe can weigh in on grout, but with their interest in mind, understanding that consensus is going to be very hard to get. So I would say let's try to go for a sounding board after we get that science talk, as opposed to trying to push advice through that isn't going to get consensus.
Thank you, Tom. Dan.
On number 6, public acceptance, I've been listening to a lot of Zooms from a lot of anti-nuclear groups, and their big leverage is transportation and disposal. And they're very nervous about both issues. And right now, our disposal paths are pretty much mixed with commercial nuclear power plant disposal paths. And if there's a way to kick this over to the public involvement program and then have an in-depth discussion as to how to approach the public and disaggregate that, so that we're talking about the intergenerational and interregional equities of the weapons program versus the power production program, and that the power production program is regional. There's some pieces that don't benefit from nuclear power, so why should they be involved in disposal of waste? Whereas weapons, whether you agree with deterrence or not, it's a nationwide benefit, it's a nationwide concern, it should be a nationwide responsibility. And the Public Involvement Committee can take a good long hard look at all of this and move us towards a path where the public can be more accepting of the waste from the weapons program in transportation and disposal. Then we're going to attack two problems at once, the drought and also the rest of the Oregon waste. And there's big questions coming up. New Mexico is concerned that there won't be enough room for the waste that is being generated in New Mexico going to the New Mexico disposal site, and they may not want waste from other parts of the country. So it's a very delicate subject. It's going to take a big, broad brush approach to the general public of the United States as well as Congress. And I think we can disaggregate ourselves from power production and just in equity terms go after for disposal of orphan waste on the site, including if we go to grounded waste. So.
Okay, Steve?
I guess, just to reiterate the excellent points, then I was gonna just lament the same thing. We have opposing opinions around, we need to have an education, understanding of both perspectives. And needs to be clearly illustrated to all of us so that we can gain insights as to why good or bad. I'm not saying either way, but I think that's ultimately what we are required to do as public representatives. And I do think that, and I appreciate what you did, Dan, in investigating where the sticking points are so we have a better understanding of what the general population is. We speak for the general population, that's all we're here for. So in doing that, I want to also commend Rob for putting together the summary of years and the conversations that have been had. And I love that as a vehicle in, because I have a tendency, and I have to admit, you go into the site, you start looking around, next thing you know, I'm down a rabbit hole, and it's like, oh, it's 3 hours late, I didn't get to what I was thinking I was coming in here for. So, I mean, having that little cue up to say, here's what we talked about previously, and I think it's absolutely imperative for people, we've got a new flush of folks coming in October, to have a reference point, because there's nothing worse than thinking, you know, oh, it's going to take me 2 years to come up to speed. Well, if they knew exactly what the conversations were over the last year, quarter, 2 years, 3 years, then at least there's giving them a chance. Right? And so I think that, and it's not that I need to be hand-led, but I need to be hand-led. I need to be given, okay, this is what I'd really like you all to be aware of, as opposed to leaving it up to myself, because there is so much information out there from so many different, it's easy to just be completely overwhelmed. And I'd like to have a vehicle to keep from overwhelming the new folks coming in, if that's possible.
Chris, and then Tom.
2 things. I was the lead process engineer for grouting all the waste at Fernald. We grouted 3,750 6-foot high canisters, 5 feet wide, sent them to McAndrews, Texas. I was in design of the grout recipe from the start of grouting through when I left to go to Southfield, England. And the problem, the issues that we ran into is we had tons of treatability studies done by national labs, by independent labs, and the very first time we grouted when we went to hot ops, it failed. We threw out every single study that had ever been done because it didn't work. Not that it wasn't stuck, this grout solidified before it got in the container. And it turns out that you can do all the studies you want beforehand, but whether you're successful or not depends upon your entire manufacturing process and the train. It depends on how you get your feed into the mixers to grout it.
It depends upon your auger systems and tanks for your cement, for your lime, whatever. It depends upon how the mixing is done in the mixing tanks itself, because you don't empty all the grout out of the mixing tank. Residual grout solidifies in the mixing tank, and then it falls into your next batch, and your recipe is gone. So we didn't have a recipe, we had dozens of recipes, and the recipe we had changed depending on the characteristics of every single batch that we ran. So we essentially had 3,750 recipes for grout, because what we grouted changed, the characteristics of the waste changed every single tank. All these are handleable. The waste acceptance criteria of McAndrews put some constraints on how we grouted. The transportation of cast to McAndrews put constraints because we could only have so much grout in tanks given the axles of the transporter trucks. The radioactivity of the grout changed the recipes because we could only have a certain amount of radioactivity for our rad techs on the outside of the containers, 2 feet away from the containers, to comply with DOT regulations. So all these things are things that I handled and handled successfully, and the team handled successfully. But if you go, my point is, if you go just on what a lot of the national studies done, the world is going to change depending on how the plant you actually grouted. That's one thing. The other thing is, Rob, I think you need to be real careful here. It's real easy to get technical on the subject of grout, and I think we need to be real careful going forward on what constitutes policy in any advice we give versus what constitutes how we're telling someone to do something. Because it's real easy in all the discussion here to slide from policy into getting technical and telling someone how to do something and doing that. So that's just a caution, because I think more than any topic that we've talked about over the last couple of years since I've been here, this is one where we have the real risk of sliding into giving advice that's technical how to rather than policy.
Yeah, can I just respond here?
Talk to me about your experience.
Okay.
I think that you're right. We have to be very clear on what we're doing. And I do believe that some technical knowledge will help people look at policy level work.
Absolutely, and let's just be clear on that distinction.
And I see whatever advice or comments that we have on grout, to me, it's going to a safer place. Whatever it is, it's going to a safer place than staying here at Hanford. That's the big thing.
Okay, if I could just step in here for a second. So I think taking a look at the work plan, what was requested from the agencies was advice on grouted low activity waste disposal, whether that come in the form of traditional advice, a sounding board. It sounds like step one in the process for the board to be able to respond to that request is to bring information to committee. And so I think we could talk all day about grout or, the path forward, but I think ultimately step one is for me to take this request back and see what and when we can bring to committee, and then touch base with both Rob and Rob.
Could you repeat that first sentence, please? Grouted waste disposal? What was that?
Grouted low activity waste disposal is, if you take a look at the work plan, that is a requested topic or a requested piece of advice that we're looking for.
DOE's looking for technical advice on disposal of grouted waste.
We're looking for, I would say, technical advice. We're looking for policy level advice on grouted low activity waste disposal. So
grout and low activity waste disposal.
So I think, the path forward here is for me to take that request back to my management team, let them know this is what the group is looking for. This is how many notes I've taken over the past 3 days. So I hear you, I'm listening, I'm taking copious amounts of notes, and I would like to make sure that I'm.
Yeah, it's way down the line from what we're talking about here.
Right, but what I'm saying is.
Six.
So step one.
We're saying the same thing, so.
Right.
It's a.
So like I said, step one for me is to take what is requested here, which is, we're looking for the science of grow. We're looking for that information that can help the group make an informed decision, right? On what it is that they would like to write advice on, provide their sounding board on, et cetera. So in order for you to move forward, you need the information is what I'm hearing. And so it's incumbent upon me to take that request back and see what I can bring you. So I don't know the answer today, but I do have it written down, and I would like to have the opportunity to come back and answer that question. Or hopefully bring you the briefing as soon as I can.
All right,
So
just wait,
My last thing
just
is
time
not
out.
correct.
We have a comment from
Yes.
Tom, and we're working towards conclusion. So let's hear from Tom and then see about wrapping
I
up.
got excited in the grant discussion, and this one I actually wanted to talk to you about. On the, on slide 8, I couldn't read whether the tank retrievals section includes dry mining or a way to get material out of tanks with holes in the bottom, that isn't sluicing or wet. So I think that would be something that I think this committee should look at.
And is that part of grow?
No,
Or
not that.
TBI?
No,
No.
it's on tank integrity and
Yeah.
recovery.
Okay, so thank you. Okay, so that's an additional, make sure it's included in that.
Yeah.
Okay. Rob, is that an understanding? Does that?
Oh, yeah, no, that's, it's really good. And like I said, is that, it may be that we get a more detailed and then a less detailed to the main board or something, if we're gonna propose some sort of a Hanford advisory board support for putting low activity waste into, more safe storage or
Discussion,
disposal.
not necessarily
Yes.
supportive.
Yes, well,
And sausage making always happens in committee, right? So
Right.
we need to bring it to committee before it goes to the
right,
full
oh,
board.
yeah, I'm just saying is that when we bring it out, that we need to take it that way.
Yeah.
All right, so have we covered the main elements of this open forum and committee business?
I have lots of notes. The next meeting Rob identified is January 9th. So I look forward to working with Rob, and if there's more questions that Rob can't answer as far as planning for that meeting, I think it would be appropriate to schedule a committee call.
Also, we need approval of committee minutes, and at a previous committee meeting in the last 2 days, we are going to be working to turn the meeting minutes quickly, bring them through DOE, and then work with Susan. Yesterday, Susan said we'd like to distribute the draft minutes to make
Made
sure
available.
when available, so that you can look at them and then become adopted, right? All right, so we heard that and we're working on that.
Pam, you had, it looked like you had some concern you were after Chris was talking. Did you have?
Oh, she asked.
I want to be sure that the Department of Energy sits down with this gentleman that has all this experience and understands he's here. And they don't have to look in a book about what happened with the silo waste. It was a national problem for so many meetings that I attended over the years, and he solved it. I mean, this is mind-boggling stuff.
And he's a marathoner, or used to be a marathoner. All sorts of stuff about
And he
Chris.
sits on
Yeah,
that.
All right.
Okay, before we close, which will be the next step, at the public involvement meeting, yes, 2 days ago, put a date on your calendar, December 5th, okay? Because we have a big Hanford dialogue, okay? And I spoke up and committed that the Tank Waste Committee would have when they break out of this meeting.
We need one conversation, just a second.
Chris, just a second.
Chris.
Just a few minutes so we can wrap this up.
Okay, so I volunteered that the Tank Waste Committee would have a table or sit at a table and take questions from anybody at this Hanford dialogue. This is a public event, so we're gonna have public there. And I think I made a recommendation that all committees go to one of the four corners of the room, whatever, sit down with a sign that says I'm Tank Waste, and come and ask me questions. And I want you to join my committee or pay attention to us or whatever. So this is in December.
Yeah, so there's two things, two things. For Hanford Dialogue, there is, an open house from 5:30 to 6, where there are booths for different presentations. And it was suggested, we still
They
have
offer,
one voice.
they actually offer the board a
Yeah,
table, so
Yeah.
Rob, you had recommended that each committee have somebody there to be
Yeah,
on
right,
that
exactly.
table.
yes,
But
so,
Not four corners.
December 5th.
that has to do with, just a moment, we're conflating two things. And because that is the open house hours and we have a process forward for that, so, yes. Hanford Dialogue, we're looking to have a booth for the HAB and committee voices at that. It's a half hour from 5:30 to 6, and then be nice to have somebody, somebody available there. All right, are there other items?
One more thing I wanted to say, Tom, you made the recommendation at the board meeting last month to hold the Hanford Site 5-Year Plan public meeting in conjunction with Committee Week, which that group was able to shift their meeting dates to accommodate that. So that will be the evening of Tuesday, October 24th.
Awesome.
So great recommendation.
Tuesday, October 24th.
In the evening,
Can we get like the meetings for HAB and any related HAB activity for the rest of the year?
so here's a question,
Can I get that?
I have a quick question. This is an
I don't
option.
mind those two.
I'm out of line, but we could put meeting invites that are placeholders for October 24th, 25th, 26th. It would have not much information other than have meeting that day. Is that
Great.
helpful? And then so that would be very broad placeholder until like 2 weeks beforehand, when all the agendas are developed, the specific things.
Don't need the agenda, just need the date.
So I think maybe Judy, what I would recommend is the weekly HAB happenings email, and I don't know if you have,
Sure.
if you read that weekly, but Josh, if you could include those evening events that are going to be in conjunction with, so like the Hanford Site 5-Year Plan, if you could put that in there.
That's another option that
It's-
it
Yeah,
has.
it's exactly, it's the related but not specific.
Got it,
Right.
okay, got it.
It's,
Let's talk offline a little bit more about
Sure.
what that might look like. Josh, we can talk about
I
that.
get a prompt for that, that helps. Make sure I can do
So
that.
folks can hold their calendars.
I'd encourage everybody to go to the website and take a look at the various presentations that people have made over the years.
There,
And Connor has wonderful presentations in there.
the last piece, and this pulls from the PIC conversation 2 days ago, is, it started from a request for Radiation 101. It talked about educational needs like lunch and learn or breakfast and learn. And then another thing that came up is that there used to be recommended resources, like reading lists or great presentations for members to be able to. So maybe we can draw on some combination of that. I guess it's to you to conclude our meeting. Yeah. Oh, Josh, meeting minutes.
The June draft meeting minutes were submitted as part of the meeting packet. Were there any comments on that?
Approved?
Approved.
Okay.
I must honestly, I go down and I look, what did I say here? What did I say here? Did I say that?
Yes, you said that, Josh. Josh heard you.
Yeah, that's right.
Okay, well, I just wanted to thank everyone for the great conversation today and for giving me some information to take back and share with, what?
Some
Oh,
information.
lots and lots of information. I've got lots and lots of notes about what we are going to be taking a look at for our January meeting, and I look forward to committee week in October. So this meeting is adjourned.
Thank you.